Hello wonderful person, this is Anton, and today we're going to discuss something else absolutely incredible coming out of James Webb Space Telescope, the largest map ever produced, at least to some extent. And in this case, this is something we refer to as a deep field map, an image representing a relatively small region in the night skies, but that basically contains thousands and thousands of different objects assembled from individual pieces and from individual long-time exposures. And though the first ever deep field was right here produced by Hubble back in 1995 and only represented a super tiny piece of the night skies, equivalent to a tennis ball at a distance of 100 meters, now we have something somewhat similar coming out of James Webb, but something that's ridiculously more complex and contains way more stuff. And more importantly, you can actually look at it yourself and observe every single one of these galaxies and every single one of these objects by using one of the links in the description. And so let's discuss this in a little bit more detail, talk about why this is important, and of course discuss the map itself. But first, a super brief overview. 6 separate galaxies from this map, representing the power of this image. And here this is intriguing because this is 6 out of 800,000 galaxies inside this image, but in this case showing us entirely different time frames. The light from one of these galaxies took approximately 3 billion years to reach us, with other light being 4 billion years old, 8, 9, and 10 billion years old. So this image shows us very different eras of the universe and allows us to study the evolution of the universe by just looking at a tiny spot. But before these pictures can even be taken, researchers first had to find one of these fields, and here this had to meet several criteria. First of all, it had to be in a relatively high galactic latitude, in order to avoid dust or potential matter in the plane of the Milky Way disk. Second of all, it has to have no known bright sources such as different stars or different types of nebula and some other emitters of infrared, ultraviolet, and X-ray wavelengths. In other words, this location has to be practically black. And this should also not contain a lot of other gas, including hydrogen gas, that sometimes produces what's known as low background infrared cirrus, a type of a hydrogen emission that's usually visible in certain frequencies, such as the infrared. And while surprisingly not a lot of locations around us seem to meet all of the criteria. As a matter of fact, back in the 90s, only 20 such fields were initially identified. And while for the Hubble Space Telescope, its initial deep field was right here, right above the Big Dipper. But the follow-up, the ultra deep field, was in a slightly different place and did involve a much larger and much more accurate image released in 2012. And while you can actually learn about some of the other fields, or I guess some of the other maps produced by Hubble in the last few decades, in one of the links in the description. But in essence, with every single observation, it revealed more and more. But there was still an obvious limitation. Hubble had limitations in observing infrared light, and while based on the predictions of the Big Bang Theory, we know that technically all of these super distant objects that contain optical and ultraviolet emissions, especially from very bright, very powerful stars, would mostly emit infrared light because of the tremendous redshift. And this is of course why the James Webb was built to begin with, and of course why all of the observations from the James Webb so far confirm the Big Bang Theory. But in order to attempt to create this map, James Webb Space Telescope had to spend approximately 260 hours observing a region of space nicknamed Cosmos Field. As you can see from this image, it at first does not look like anything special either. And here's how it compares to the Hubble Ultra Deep Field. This is way larger. Here this is based on the Cosmic Evolution Survey collaboration, covering a tiny arc approximately 0.5 degrees squared, or about as much space as the Moon takes up when viewed from planet Earth. But once again, looking at something that's practically black and seems to contain nothing visible from the planet. Based on the criteria for this selection, it contains no stars, no galaxies, no dust, no nebula, pretty much nothing. This was a tiny dark spot. Or technically it contains some stars, but they're extremely dim. And so for the first few years of the James Webb operation, it essentially observed this region several times, capturing a lot of data in the mid and near infrared emissions. But for all these years, this data was basically inaccessible, or it was actually there, but it was not processed and could only be used by someone with very technical knowledge of how this data should be processed. In other words, this was pure raw data that was just very difficult to use. But thanks to Caitlin Casey of UC Santa Barbara and the team that helped her create this, we finally have publicly available dataset that's now visible to everyone, usable by everyone, and can be used to discover incredible new things. And it literally represents the largest galactic map of the universe created to date. Now, there are some bigger maps created in 3 dimensions by, for example, Dark Energy Survey, but those are not really produced in the same way and do not show us the same data. Here, we basically get the clearest image of the universe, representing 13.5 billion years of galactic evolution, or basically showing us almost the entire cosmic time. And all you have to do to look at it is click this button, because as I mentioned before, this is an actual interactable image. And though it doesn't look super special from a distance, once you actually zoom in, this is when you basically get your mind blown. Even though from a distance it doesn't really look like there is much, as I mentioned in the beginning, there are 800,000 different galaxies in here, with many, like this one right here, never explored by anyone and currently completely unknown. And though there are still some stars here, like this bright object in the middle, the vast majority of other objects are basically strange, distant galaxies. And some of them actually kind of make no sense, like, what is this? And also, what is that? Or look right here, there's a colliding galaxy. And because of the redshift, we can basically assume that this is billions and billions of years old. As a matter of fact, I've been exploring this for approximately half an hour now, and there's some really cool stuff here. Like for example here, I think this kind of looks like an Einstein lens, or some kind of a gravitational lensing effect that seems to stretch the light from these galaxies just a little bit. We also get the mysterious red dots all over the place, and a lot of really bizarre looking galaxies, some of them stretched into some weird shapes, but exactly why is of course currently unknown. Mostly because, like I mentioned, this is actually the first time a lot of these galaxies have ever been seen by anyone. But just the sheer amount of galaxies in this image is absolutely mind-blowing. And remember, this was seen in something that appears completely empty to our regular telescope from planet Earth. Yet to the James Webb, nothing here looks empty at all. And so I guess the main achievement here is that all of this previously inaccessible data is now publicly available and will probably lead to some incredible discoveries in the next few months. And that's actually the main point behind all of this. In the words of the main researcher, democratization of scientific data, and making all tools and all scientific data available to everybody, even if they don't have access to the best telescopes. And so now, amateur astronomers, undergraduate researchers, and of course general public like you and me, can see all of this directly from your browser. But obviously there was always the main point for this, and to some extent the main question. Do a lot of these observations coming from the James Webb break any of the cosmological models? And especially because when we compare this to some of the older observations and older predictions based on Hubble, here we literally see approximately 10 times more galaxies than expected and predicted, especially at these very far distances. And though to some extent this actually explains why previous studies discovered a little bit more background light coming from the universe than expected, it's currently unclear why there seem to be more galaxies than we ever thought, and why in certain locations we even seem to detect supermassive black holes that were previously invisible and unknown because they were just super far away. And so here not only do we have 10 times more galaxies, we also seem to have way more black holes. Like for example, there's a really big chance that this is maybe one of them. And so to some extent, this does challenge the current understanding of the universe, or at least the understanding when it comes to the baby universe. The early universe does not seem to make a lot of sense compared to previous observations. But the other main achievement here is the actual size of the map. If we compare all of this to the observations from the Hubble and one of the biggest deep field maps created by Hubble, the one that contained approximately 10,000 galaxies, here as you can see in this video, this map is dramatically larger. And because it also covers approximately 98% of the cosmic time, it allows us to test something else. This extremely wide view of the cosmic environment allows us to see not just how, but also in what location various stars and galaxies started to form. And specifically, it allows us to see the cosmic organization. Or in other words, by assessing how many galaxies and, I guess, different objects we tend to detect in certain regions, because of this deep field, we can now start mapping the cosmic web even better, figuring out distances of various galactic clusters, what kind of galaxies formed at what time, in the process mapping the concentration and the location of most of the galactic mass. And though some of the previous observations from the Hubble telescope suggested that we're not actually going to see a lot of galaxies in the first 500 million years, here, by zooming in just a little bit, this assumption is basically proven wrong. And so in this map, we seem to see billions of solar masses of material existing as far back as 13.5 billion years ago, when the universe was only about 2% of its current age. But why and how this happened is of course the biggest mystery today. Which is why this map is most likely going to be one of the most important maps in the next few years. Because this is now publicly available, there might be some galaxies and some unusual objects located in here that could help us resolve some of these cosmological mysteries. But also potentially help us understand mysteries such as the dark matter, because even in this image, we seem to observe effects of this dark matter as tiny gravitational lenses all over the place. But it's really objects like this that are going to be very likely the main focus. We still have no idea what these objects are, why they seem to exist at these very far distances, and as one of the recent studies proposed, maybe these are actually dark matter stars. Hello wonderful person, this is Anton, and in this video, we're going to be discussing some of the new observations out of James Webb Space Telescope of an unusual distant galaxy that potentially represents the first ever detection of a very mysterious type of a star known as the population 3 star. Or to be more specific, we're going to be discussing a detection of a galaxy that seems to be made entirely out of first stars in the entire universe. And so let's talk about this in a little bit more detail, but let me first explain exactly what these population stars are and why detecting these stars is one of the main missions for the James Webb. And here all of this connects to the idea known as metallicity, the astronomical concept that basically defines elements in the universe as either metals or not metals. And in astronomy, there are only two non-metals, hydrogen and helium, with everything else after hydrogen and helium basically being referred to as metals. And though maybe not the best name to represent all of these elements, in essence what this means is that some elements like hydrogen and helium existed since the beginning of the universe. But everything after this, so things like carbon, oxygen, and pretty much most of the things on the elemental table, was actually created as a result of astrophysical processes. So basically everything from carbon to iron and gold. And over time, as the universe evolved, the fraction of metals compared to non-metals increased. So basically, even though initially there was mostly hydrogen and helium, as various stars were born and as supernova happened, and basically as the universe became enriched in a lot of additional elements, the entire universe started to become more metallic and chemically complex. And so in astronomy, this concept of metallicity is super important. But it's especially important when it comes to trying to figure out the star's age and the evolutionary process in regards to stars, and to basically find out how different types of stars evolved from one to another. And based on this metallicity concept, today in astronomy, all stars are divided into three different types: population 1, 2, and 3. And while stars like our Sun are basically some of the youngest stars and contain some of the highest amount of metallic elements, so essentially they contain a lot of stuff that's not hydrogen and helium, implying that they were formed after many supernova happened in the past. For example, for the Sun, it's actually believed that at least 40 supernovae happened to create the amount of metals we observe in various solar emissions. And so when we look at the star and we discover that it's a population 1 star, or essentially a star with high metallicity, we also know that it's most likely going to have a planetary system along with potentially terrestrial planets. Naturally, because planets like Earth are made out of a lot of these metallic elements. As a matter of fact, Earth is composed of approximately 90 chemical elements, actually being mostly made out of oxygen and silicon and not hydrogen and helium, with Earth's core also containing a lot of iron, which is one of the end products for a lot of different supernovae. And so for planetary sciences, population 1 stars are usually the most exciting. Then we have population 2 stars, basically the stars that eventually created population 1 stars like our Sun, and the stars that do contain fewer metals and are usually much older, but also obviously do contain some elements that are not hydrogen and not helium. Today, most of the red dwarf stars are actually population 2 stars, but the more massive population 2 stars resulted in supernova and eventually produced stars like our Sun. But then there is the third population that we've never seen anywhere, and that's the mysterious population 3 stars, I guess the grandparents or the progenitors of everything. And these would be stars containing no metals, because these would be the first stars to appear and would be very likely extremely different from anything we've ever seen. Now, based on a lot of simulations, these stars are expected to be supermassive, very bright, and very hot. Basically, blue hydrogen helium stars, possibly several hundred times more massive than the Sun, and very likely only existing for maybe 1 or 2 million years. Which, as a result, means that it would be extremely difficult to actually capture them with a telescope, because their lifespan is not very long, and because we're mostly going to be seeing the leftover gas after the supernova, or possibly seeing population 2 stars that formed from all of this gas. And so, based on a lot of different computer simulations and very detailed simulations, researchers essentially worked out what we should be detecting if we ever find them, and what these stars are most likely going to be producing in terms of the actual emission lines. And while in the last few years, there actually have been some hints of these stars, or at least their remnants, in a few different galaxies. For example, a few years back, we've discussed the detection of potential gas produced by these stars. And here this was basically gas that was very likely produced as a result of massive supernova, which implied that we're seeing what happened after these stars exploded, or that we basically missed these stars by just a few thousand or a few million years. You can learn about these discoveries in some of the previous videos or in some of the studies in the description, but this is basically what the scientists kept discovering over and over, either remnants or obscure signs that these stars potentially existed, but no exact detections yet. But approximately a year ago, we discussed this study, based on the observations from GNZ11, or the previous record holder for one of the farthest galaxies ever found, where scientists discovered the telltale signs of these unusual stars. Here there was what's known as the HELL line, or technically helium-2 line, which is a type of an emission usually produced by extremely hot helium. And here this could only be explained if this gas was strongly ionized by something super bright and super powerful. And it was actually located right here in the halo of the galaxy. And whatever this was, it was at least 500 times more massive than the Sun, which at least in theory resembled the mass of these hypothetical population 3 stars. And though once again not the exact observation and just the hints of these stars, this observation once again confirmed that the theories in this case might be correct after all. And well, now, approximately a year after, in 2025, we get a new study that potentially discovers even better evidence from a completely different galaxy, reported by Fujimoto and his team in a study you see right here. And this is based on a survey using James Webb Space Telescope known as GLIMPSE. And this survey contained 2 barely visible galaxies that researchers discovered were kind of unique and somewhat unusual. Unusual in a sense that they actually contain all of the parameters predicted by these population 3-star theories. And though one of the galaxies was just a candidate and the observations were not perfect, the other galaxy, known as GLIMPSE 16403, turned out to be super exciting. Exciting because this is the first time we've seen anything like this. First of all, this was an extremely compact galaxy. It's only approximately 140 to 150 light years across, and technically resembles some kind of a globular cluster, or an extremely early galaxy growing really fast. But much more importantly, it actually contained all 3 main features for population 3 stars. First of all, it had a very strong hydrogen alpha emission line. It also contained something known as the Balmer jump, and most importantly, it seemed to contain no dust and no additional elements indicating metals. In other words, if we actually compare this to the model or the prediction for population 3 stars, this galaxy was almost a perfect fit. But intriguingly, this galaxy existed when the universe was already 825 million years old. So this was actually closer and younger than the previously discussed candidate GNZ11. But because this galaxy contained very powerful hydrogen and helium emissions, and no signs of any metallic emissions, there was really no way to interpret this except for a galaxy with these population 3 stars producing huge amounts of luminosity, and essentially stars that are probably going to be exploding very soon and producing additional elements. But as of right now, all of the stars in this galaxy seem to be pretty young, less than 5 million years old, with a total mass of all stars only being approximately 100,000 solar masses. So this is actually a really small galaxy, and even small for a typical globular cluster, suggesting that this is a galaxy that seems to be forming out of some kind of a primordial gas in what seems to be the middle of nowhere. And though it's still possible that this is just some kind of a metal-poor galaxy, or even some kind of a black hole or an active galactic nucleus, so far these are just alternative explanations, and the best explanation based on the emissions seems to be that this is indeed population 3 stars and not something else. And so whatever is happening in this galaxy is definitely going to be discussed in a lot of future studies, because this is actually super exciting. We've never seen such a primordial galaxy ever before, and this could basically represent some kind of a really early seed for some of the future galaxies, where all of these stars, as they go supernova and as they produce a lot of new elements and a lot of additional emissions, continuously enrich the region around themselves and possibly eventually grow larger and larger as more gas falls in and as this galaxy collides with additional galaxies. So for all we know, this is basically the first ever detection of a primordial baby galaxy. Literally a galaxy that's just a few million years old and was just created. But we need to have more observations and additional work before this galaxy and the additional candidate can be confirmed. Although assuming that this is correct and assuming that this is indeed population 3 stars, this would suggest that one of the primary missions for the James Webb has officially been completed. Discovering these stars and studying them is essentially one of the main reasons this telescope exists. And because this is such a grand discovery, here the researchers also end their paper on a somewhat philosophical note, basically reminding us that only 100 years ago, cosmologists finally discovered that the universe existed, and galaxies like Andromeda and Triangulum were actually separate galaxies and not part of the Milky Way. We've actually talked about this very recently in one of the videos in the description, but back in 1925, Edwin Hubble and a few other astronomers officially confirmed that the universe was much bigger. And now, 100 years later, we're talking about discovering some of the first galaxies at literally the edge of the universe, which is kind of mind-blowing. Hello wonderful person, this is Anton, and today we're going to discuss some of the recent observations and recent somewhat unusual discoveries coming from a very intriguing star system that basically looks like this. An extremely unique star system discovered a while back that's now referred to as Apep, named after the mortal enemy of the god Ra in the Egyptian mythology. But one of the main reasons this star became very famous in 2010s is because of what potentially might happen to this star system in the next few thousands of years. As of 2025, this is probably the best progenitor candidate for what's known as a gamma ray burst. A really powerful explosion that produces enormous amount of power, with all of this power concentrated in an extremely compact jet. And naturally, if such a jet is pointed toward planet Earth, it does have a chance to possibly cause an extinction event. But here, based on the observations from the star, it was pretty quickly established that even if the gamma ray burst is produced, it's unlikely to be headed toward us. Nevertheless, this star, along with the Eta Carina NWR104, has officially become the possible future gamma ray burst's progenitor, with a slight chance of maybe affecting Earth. But extremely recently, in July of 2025, researchers observed this star with the James Webb, discovering a few more things about it, and learning a few more things about the star system, which as always kind of surprised everyone. Which means that we have to talk about this star system once again. And really because this is not just some kind of a distant celestial object, this is a cosmic marvel. It kind of challenges our understanding of stellar evolution, and potentially offers critical insights into some of the most powerful phenomena such as the gamma ray bursts. But first, let's talk about what we know so far and what sort of a star system this is. And to begin, well, this is not very close to us. It's approximately 8,000 light years away from Earth and seems to be a triple star system. But when this star system was observed in 2016, because of its bizarre appearance and because of its similarity to some kind of a snake, it eventually received a nomenclature of Apep, the Egyptian snake god. But in this case, this shape is just a vast complex of stellar wind and cosmic dust, with the shape itself somewhat similar to another star we recently discussed, known for producing very bizarre shells. Here we're talking about WR140, the Wolf-Rayet system we discussed recently in one of the videos in the description. And well, as you can imagine, this is also a Wolf-Rayet system, specifically a Wolf-Rayet binary that also contains a third hot supergiant orbiting in the north. And just as a reminder, Wolf-Rayet stars represent a very dramatic stage in the life cycle of a massive star, usually right before they explode as supernova. And this is when a lot of stars violently shed their outer shells, leaving behind exposed cores that then generally go supernova. And the stage is characterized by very powerful streams of gas and stellar wind that, as we've learned recently, seems to enrich the entire galaxy in a lot of dust and a lot of complex molecules. That's actually from that previous video from just a few months back that you can find in the description. But this is also an extremely brief stage, usually only lasting for hundreds of years or sometimes a few millennia. But unlike other Wolf-Rayet stars, Apep is particularly interesting. And that's because here we have two classical Wolf-Rayet stars orbiting one another. One of them is what's known as the carbon sequence subtype, and one of them is a nitrogen sequence subtype, making this one of the few known cases of a classical Wolf-Rayet binary system. But obviously, the most remarkable feature of the system is how it looks. It seems to contain a vast complex of stellar wind and cosmic dust that seems to surround the system and expands in every direction, with the material forming what's known as a pinwheel shape, very similar to other pinwheels we discussed previously. And once again, this is super important for the entire galaxy because these are dust-producing factories. As a matter of fact, some of the previous studies, including the one in the description, have definitively shown that a lot of this dust seems to be more or less organic in nature, and quite a lot of it is then very likely responsible for enriching new stars and eventually causing the formation of planets enriched in organic materials. And there is a very high chance that something very similar to this potentially caused the formation of planet Earth, eventually enriching it in organic matter. But in order to form this dust and in order to create all of these complex organic molecules, this involves an extremely powerful process with super powerful stellar winds coming from both stars, clashing with each other, creating a lot of density and a lot of compression, which forces a lot of these elements to initiate complex chemical reactions, resulting in the production of a lot of compounds we very often associate with organic molecules. And this is very likely how some of the earliest carbon dust in the entire universe was created as well. As a matter of fact, most of the stuff inside of us was very likely formed in a similar way. But it's the orbital motion of the stars that then wraps all of this dust into this spiral shape and sprinkles it across the galaxy, with most of this gas then moving at very high velocities, usually hundreds of kilometers per second, or approximately 1% of the speed of light. But in this system, some of this dust seems to move much slower, which indicates that at least one of the components in the system seems to be rotating rapidly. So fast, as a matter of fact, that its surface gravity seems to be balanced with the outward centrifugal force, which basically results in slightly different stellar winds on the equator compared to the polar regions. We have a lot of fast winds coming from the poles, but much slower winds coming from the equator. And it's the interaction with these slower winds that then creates this very unique pinwheel shape. But compared to other pinwheels, this one is just a little bit different. And that's because, as I mentioned, this is a unique binary system. Instead of one powerful star dominating weaker companion, here Apep features very similar stars with near equal strength of winds, resulting in the dust being spread out in a very wide cone of dispersion. But some of the features of this shape were still difficult to explain, and so these new observations from the James Webb Space Telescope potentially provide us with some answers. And well, first of all, here's what this new image looks like. In my opinion, this is even more beautiful and more mysterious. But we now have a potential answer for why this shape is so bizarre. It's probably because of that third star. The third hot supergiant that orbits the central binary seems to have dramatic effects on changing the shape, even though it orbits 1700 astronomical units away from the system. Here a single period is approximately 10,000 years. And at first, researchers were not certain if that third star was even in orbit or if it was just passing nearby and seemed to be in the same location completely by accident. But the James Webb Space Telescope, equipped with its very powerful infrared camera, was able to provide a lot more detailed data. And well, the first observation is that there seem to be 3 more distinct dust shells that become visible if you zoom out of the system, and that also seem to be cooler and fainter. But they're spaced perfectly evenly against a background of swirling dust. But there's also something else in this shape that only became visible to the James Webb. Here, this new data revealed a distinct bite taken out of this dust shell. And this type of a bizarre carving usually occurs where the wind of the third star interacts with the dust from 2 other stars, in essence conclusively proving that the third star is physically bound to the inner system and confirming this as a triple star system. Otherwise, we would not be seeing these bizarre deformations that seem to be relatively regular. But these new observations also suggest that the star is probably a little bit farther away than we initially thought. Not by much, but probably by a few hundred light years. And the shell that you see in this image seems to have been created in the last 700 years, with this dust shell expanding every single year. This was determined using a computer model that allowed for very precise decoding of what seems to be happening inside. And so because they're much farther away, this implies that the stars are extraordinarily bright. But also very likely challenges the initial claim that one of the stars is rapidly rotating. Which of course means that we still have so much to learn about these stars and about their evolution, especially because these very strange nebula seem to be indeed crucial for the evolution of galaxies and the formation of planets. But this star seems to be the most important discovered so far, because the age of the dust around it is way older. That previous SHELLQ star we discussed a few weeks ago only shows us dust that's just over 100 years old. But in this image we see dust that's at least 700 years old, with the dust also exhibiting something we've never seen before: destruction of the dust by a third companion in orbit around the central binary. And so because these stars have now been established to be crucial for the enrichment of planetary systems and possibly the formation of complex planets, these new observations and these new studies take us just a little bit closer in helping us understand how terrestrial planets seem to form, what life needs on those planets in order to thrive, and where all of this potentially started. But if you'd like to learn more about this, check out the study by Ryan White and the team you see here in the description below. And so on that note, that's pretty much what I wanted to mention. Prior to the observations by James Webb, a lot of these Wolf-Rayet stars were actually quite mysterious and seemed to produce effects we just could not explain. But because of these new infrared observations, and because of several new studies based on the observations of infrared emissions, in just the last 5 years we've gained a lot of understanding of what seems to be happening here, highlighting the importance of studying these stars and their importance when it comes to the evolution of the entire galaxy. Well, it's been a while since we've talked about the mystery of little red dots. Really bizarre, mysterious, and still unexplained objects discovered by the James Webb Space Telescope a few years back that all kind of look like this. Literally, little red dots. But today we're going to discuss at least 2 different studies that actually make some exciting discoveries and exciting propositions that present us with some other new ideas and actually do discover something extremely close to us that now has a chance to potentially explain everything once and for all, assuming we get new observations relatively soon. And so let's discuss some of these new studies in more detail, but I guess first, a very brief overview of what exactly we know about these objects, or I guess more realistically, what we don't know. And while in general these little red dots, or LRDs, all seem to be super ancient, they're also relatively faint, but more importantly, they're only visible in some wavelengths, which is why only James Webb Space Telescope was able to discover them. They were previously invisible to the Hubble telescope and to all previous observatories. And some of them seem to be super old. They essentially existed approximately 600 million years following the Big Bang. But as of today, almost 350 such objects have already been confirmed, and most of them seem to exist between 0.6 to approximately 1.6 billion years since the beginning of the universe. Or just to rephrase this, 13.2 to 12.2 billion years ago. And all of them possess extremely similar emissions. But interestingly, every single one of them is extremely red in color, which potentially suggests huge amounts of gas, lots of different dust, or something else covering something really massive and very powerful in the center. With additional observations also suggesting that these objects potentially spin very fast, based on the observations of hydrogen lines or the Balmer series lines, which seem to be extremely wide in comparison to other objects. This can only be explained if something is spinning very fast around the center, with at least one previous study calculating the velocity of spin at approximately 1000 km per second, which of course implies something very massive in the center, potentially some kind of a supermassive black hole. But on the other hand, they also possess certain properties that are very difficult to explain. For example, there are no X-ray emissions, and if these were supermassive black holes, that's actually kind of difficult to explain. To date, almost every active black hole has always emitted a lot of X-rays and a lot of additional energy. On top of this, their infrared emissions are more or less flat. or basically they seem to possess a relatively similar temperature. But the strangest mystery, especially if this is black holes, is the fact that they seem to have very low variability. They don't flicker much, they don't change in brightness much, they generally seem to have very similar brightness over time, which is once again not what we expect of a black hole that's constantly consuming a lot of mass. Every black hole we've seen so far, especially massive black hole, has generally flickered and changed brightness a lot, very often in mere hours of active observations. With additional mystery also just being the fact that we don't seem to observe these in much older universe or at lower redshifts, which imply that these objects potentially only existed in the first 2 billion years of the universe, transforming into something entirely different. Possibly into something like this, that was also discovered not so long ago, and that you can learn more about in one of the videos in the description. But there is a new study that proposes that maybe this is something entirely different, and something that could potentially solve at least one of the mysteries in the universe. The mysteries of how supermassive black holes came to be. And so in this first study, researchers assume that, okay, maybe these are not galaxies. Maybe, instead of being active galactic nuclei, or even instead of being supermassive black holes, these are actually hypothesized supermassive stars, SMS. Hypothetical stars with masses in thousands or even hundreds of thousands of solar masses that could have existed a long time ago and eventually collapsed, forming first supermassive black holes. And over the years there's been a lot of propositions and a lot of hypothetical explanations for their existence, with all of them predicted to be very luminous, very hot, but potentially have short lifespans because they would consume fuel extremely quick. But they were all expected to be very massive and potentially very large, with the average mass of 100,000 times the mass of our Sun. And they were also hypothesized to have formed in the early universe, but would only exist for just a few million years before transforming into something else. Although here their transformation would not cause a supernova, they would basically just collapse directly into a supermassive black hole. But while to date their existence and their explanations have always been based on various simulations and not really actual observations, obviously because we've never seen them anywhere. Which is of course what this study tries to tackle. And so because the idea here is that these stars could only form in the early universe, and because they would then collapse into supermassive black holes, here would make sense why these little red dots seem to only appear in the early universe and also seem to appear relatively similar to one another. And so here, based on the observations of their spectrum, and by comparing them to other stars, the main conclusion in the study is that these little red dots seem to represent direct photospheric light of these massive accreting supermassive stars caught in their final act right before the collapse. The collapse that should only take maybe 1,000 years. And so essentially what the researchers are proposing is that this is literally the final stage before the formation of a supermassive black hole. And while here the short lifetime of these objects would be consistent with the rarity of little red dots, while also explaining why we don't see them in much older universe. But to try to prove their point further, researchers also created an atmospheric model for these stars, suggesting that overall they should contain no metals and only contain hydrogen and helium, in essence representing these very massive population 3 stars that would have very unique emissions. And while right now the simulations do match the luminosity of LRDs and the spectral features observed by the James Webb, although here there's maybe one side note. This is only actually based on 2 objects. The object referred to as MOM-BH1 and the object referred to as the cliff. This has not been applied to 300 objects known to us. And so at the moment this is just a hypothesis, but a somewhat interesting hypothesis that does try to explain these somewhat strange objects as literally very massive stars, progenitors to a lot of supermassive black holes we observe today. Which, if correct, would actually solve a lot of mysteries all at once. The mysteries of population 3 stars, which we're still looking for, the mysteries of how massive black holes seem to form so early, and of course explain what these objects even are. But there's maybe a slight problem with this study that literally came out a few days after the initial publication. And the problem here is with one of the assumptions. The assumption that we don't see these objects in the much older universe or in the much lower redshifts. Because it turns out that that's not correct. Which takes us to probably one of the most exciting studies about little red dots in the last few years. The discovery of LRDs in the local universe. Because apparently, they do exist closer to us, and they're not unique to the early universe after all. And that's of course a super exciting and a somewhat bizarre discovery that kind of invalidates a lot of these previous ideas and previous propositions, suggesting that, okay, maybe we have to go back to the beginning and try this again. And so let's discuss this particular discovery because it's actually super exciting and find out what's going on here. And this is of course very unusual, mostly because the location where these objects were discovered is at least 12 billion years old. In other words, it's just about 2.5 billion light years away from us in a much older universe. With the discovery in this case illustrating that the conditions required for little red dots is not exclusive to the early universe. And well, as always, this discovery was made completely by accident. Here by using an older survey known as Sloan Digital Sky Survey with a telescope in New Mexico, scientists discovered 3 separate objects that looked exactly like little red dots discovered by the James Webb. As a matter of fact, they seem to fit every single property, and there was absolutely no difference between this and the ones I showed you previously, except of course the redshift. These existed 13 billion years ago, whereas the images from these objects seem to be only 2 billion years old. And ironically, we still have no idea what we're looking at. Here, each of these objects is about a million times more massive than the Sun, but strangely enough, only has the size of the solar system. So here we're talking about very massive, extremely compact objects, with one of them currently referred to as the egg because of its somewhat unusual elongated shape. And well, right now, the only thing we know about them is that they seem to match exactly what the James Webb discovered, but they seem to be very different from any other object known to us, and that includes black holes and of course stars. And so here once again these objects are very compact, they seem to have flat infrared emissions, they seem to have very broad hydrogen lines, suggesting something spins very fast, seem to produce no X-rays, and seem to have no variability or no flickering. With that one elongated object referred to as the egg, the object that you can also see pictured in this image, surprisingly having temperature very similar to a typical yellow supergiant star, but also containing quite a lot of calcium, quite a lot of sodium, some potassium, iodine, and even iron. And these strong metal absorption lines are almost never seen inside galaxies, near central black holes, or even in interstellar medium. As a matter of fact, it actually seems to resemble a typical supergiant or a hypergiant star, with researchers concluding that this seems to be the result of a very thick gas envelope that seems to be very similar to stellar atmosphere, basically making this object appear as a huge star from a distance. As a matter of fact, even the temperature and the lights coming from this object seem to appear star-like. But in this study, the researchers do not propose this to be some kind of a supermassive star. Instead, they actually do think these are progenitors to supermassive black holes, with much smaller black holes in the center, surrounded by an enormous amount of gas that then starts to emit a lot of hot radiation, giving rise to the emissions that make it appear as a typical star-like object. And if we were to somehow illustrate this, it would essentially look like this. But more importantly, they also propose that the slight deviations and slight differences we're observing, especially when it comes to the egg shape of this object, basically comes from the point of view. By observing this object from a certain direction, it will just appear slightly different, which actually does make a lot of sense. But in a nutshell, their explanation is that this is a black hole surrounded by a huge amount of gas, which starts to create star-like emissions of massive proportions. But obviously this is just the first explanation and some of the first observations. As a matter of fact, because these objects are so close to us, future observations with the James Webb and the Hubble will definitely help us figure out what's happening here. But the overall conclusion from both of these studies is essentially that these are primordial supermassive black holes, representing the early stages of the formation of very massive black holes we often find in centers of various galaxies. As a matter of fact, there might be a lot of stuff around these objects, and possibly even a lot of stars and a lot of gas, but because they're so bright and because there's so much energy coming from the center, we just cannot see them, simply because the central object is way too powerful. Or maybe these are supermassive stars after all, as the first study tried to explain. Either way, for now at least, it's a little bit unclear, but this is definitely one of the most exciting discoveries about these objects in the last 3 years. And so hopefully in the next few months, we'll start getting some answers, focusing on questions like, what's the connection between this object and various supermassive black holes? And why are these objects so rare to begin with? Okay, let's start this video with a picture of the galaxy we're discussing. It's right here. And yeah, you cannot see it very easily. And that's because this is an extremely dim dwarf galaxy, surprisingly close to the Milky Way. Which is why originally when I was going to make this video, I was going to name it something like the darkest galaxy hiding a massive secret. But that was a little bit too cheesy, so I think I changed it to something else. Anyway, hello wonderful person, this is Anton. Today we're going to be discussing some of the new discoveries from this very bizarre and very unusual dark galaxy not so far away from us, that for many years was a little bit mysterious and also just a little bit difficult to explain. But a galaxy that also presented us with the perfect opportunity to study the biggest mystery in the universe, dark matter. And that's because previously it was believed that the only reason this galaxy can exist was basically if it was made out of dark matter, as nothing else made a lot of sense. And mostly because of this. This is kind of what this galaxy looks like. It's just a few stars and a few very bright objects that seem to orbit a relatively dense environment super quick. And so if something was not holding these stars together, they would have already fell apart and became their own individual objects. Yet because they seem to be orbiting the center, the best explanation here was dark matter. Some kind of an invisible massive matter holding everything together, which obviously exists in a lot of other galaxies as well. And normally when scientists study dark matter, they do actually look for these dwarf spheroidal galaxies because they present us with the best possible chance to understand what's happening. This would be galaxies like this, NGC 147, or even this. This is much closer to us, known as Fornax. And that's because a lot of these galaxies are very compact, they contain a lot of stars, but also seem to contain a lot of mass because otherwise the stars would fall apart. So here the only explanation is that they seem to be dominated by dark matter. And amongst all of these dark matter galaxies, especially galaxies that are barely visible, one of them really stood out, Segue 1. That's basically what you're not seeing here. Mostly because this galaxy holds the record for the largest ratio of dark mass to visible mass ever measured anywhere. With one estimate putting the ratio to about 1000 to 1. Basically for one visible mass, there seems to be 1000 invisible particles holding everything together. Now for a typical galaxy, like for example for the Milky Way, this ratio is usually much lower. Something like 10 to 1 instead of 1000 to 1. Which made this galaxy very exciting. It was essentially the poster child for dark matter dominated objects. And because this was so close to us, about 75,000 light years away from the Sun, it also made it super easy to study. But that's until some of the most recent studies from 2025. Here, a lot of these new studies started to change our perspective on what's possibly happening in this galaxy, and started to suggest that maybe it's not all dark matter after all. Or specifically, what we thought was purest example of a dark matter halo might actually be something much cooler. It might be an extremely massive central black hole. With this discovery, if confirmed, basically challenging some of our perspectives, and even some of the ideas we have about evolution of dwarf galaxies. But first, let's discuss this galaxy a little bit more, and what we know about it based on a few previous studies. So once again, Segue 1 is a satellite of the Milky Way. Basically, it's orbiting the Milky Way galaxy and was potentially disrupted and destroyed by the Milky Way, eventually assuming a permanent orbit. And this is also a dwarf spheroidal galaxy, but in this case containing just a few stars. And because of this is also the faintest such galaxy known to us. There are basically only like 1000 stars in total. And that makes it actually one of the smallest dwarf galaxies in terms of stars. In comparison, most of these galaxies usually have at least 1 million, usually several million. And these stars are so sparse and so diffuse that even trying to figure out which stars are part of this galaxy becomes extremely difficult. So it actually took a few years even to identify what's part of this galaxy and what's not. And by the way, you can actually learn about the initial discovery of this galaxy in one of the videos in the description. But what makes Segue 1 exciting for astronomers is the fact that it's also a kind of a time capsule. Or at least a time capsule in terms of composition. This is a chemically primitive galaxy and seems to contain extremely ancient stars, with astrophysicist Anna Frebel referring to this galaxy as an evolved fossil. Basically an extremely early galaxy that hasn't changed much in the last 10 billion years. And though in a normal galaxy, stars usually explode and enrich the environment with a lot of metallic elements, basically through constant supernova, which happen over and over and over again, here this stage seemed to have been skipped. because none of these stars are chemically evolved, and Segue 1 appears to have halted the process of evolution very early. As a matter of fact, previous calculations established that the entire chemical evolution here was possibly only caused by like 1 or maybe 2 supernovae in total. Or just to rephrase this galaxy only witnessed a few supernovae of its own, with all of these stars remaining primitive. And because this galaxy did not have enough gas to keep growing, it eventually stopped making new stars and very likely remained this way for billions of years. But there was always this question of, so what's holding it together though? Why exactly are these stars not flying apart? And how can they be orbiting around the central point so fast? And so by studying the movement of these stars, or the star kinematics, researchers set out on the dark matter hypothesis. And here this hypothesis suggested a massive amount of dark matter, and actually for one simple reason. As many of these dwarf galaxies orbit the Milky Way, they're actually also being tidally stripped and pulled apart, eventually turning into a very long string of stars referred to as a stellar stream. There's actually a new video about this coming out soon, so subscribe and stuff if you want to learn more. But in this case, this galaxy was not turning into this, and something very massive was holding all of these stars together, avoiding a much larger gravitational pull from the Milky Way. And a lot of analysis over the years resulted in basically the same conclusion. This had a lot of dark matter, or at least that was the main hypothesis for many years. But these recent studies started to think about this a little bit differently. They actually focused on some of these stars, especially on the outskirts, that seem to have already been stripped away by Milky Way and were no longer gravitationally bound to Segue 1, which would allow researchers to basically work out a kind of a mass profile for the entire galaxy. And so basically here, by doing something known as tidal correction, researchers produced a robust analysis of the mass structure around the galaxy. And so once the data was reanalyzed and some of the contamination was removed, here the new data revealed a very important clue about the internal dynamics. Segue 1 contained a large and significant increase in rotation the closer to the center you got. Or basically, when it comes to the mass distribution, there seemed to be way more mass near the center compared to the outskirts. And this would be very difficult to explain if this was dark matter. And to be more specific, the overall velocity of these stars was about 4 km per second orbiting the center, but when you get closer and closer to the center, the rotation seems to jump dramatically, with stars orbiting at 9 to 14 km per second. And to researchers, this suggested that there was actually something very massive and very large right in the middle. Basically here, the sharp dramatic rise in rotation is a very strong indicator that there is a very large, very compact object in the middle. So here we're talking about a massive black hole. And so additionally, by using the advanced computer model called orbit-based dynamical model, they were able to figure out the overall mass distribution with even more accuracy. And then by testing different scenarios and by trying to compare theory with observations, mostly by varying 4 different components such as mass of stars, properties of the dark matter halo, and the potential mass of the central black hole, researchers discovered that only some of the models made sense. And so, for example, if they excluded a black hole, the models that fit the data required a dark matter halo profile with an extremely small scale radius, suggesting that the dark matter had to be unbelievably concentrated in the center, which has never been seen before anywhere and would not really make much sense. Normally we expect dark matter to be sort of all over the galaxy, and especially on the outskirts. Furthermore, all of the models without a black hole required stars to be on a highly radial orbit, with this particular structure being very unlikely and very rarely seen in any of the other galactic systems. But things became much easier if they actually assumed that there was a black hole. By including a central black hole, things made a lot more sense. For example, the orbital structures suddenly made sense, with stars moving randomly similar to other systems, and the motion of stars near the center also suddenly made sense, because in this case they would be just orbiting the black hole. As a matter of fact, they seem to be moving in a very similar way to what we observed near Sagittarius A star, the central black hole of the Milky Way. And so for Segue 1 to make sense, here it has to have a black hole of approximately 450,000 solar masses, which is roughly around 10 times smaller than the one in the Milky Way. And this measurement was quite robust and made a lot of sense even if there was a lot of dark matter as previously predicted. Which basically suggests that the central gravitational dynamics in Segue 1 seem to be mostly driven by a single black hole and not necessarily just the dark matter halo, although in this case the dark matter is still present as well. But if confirmed, this is a new mystery, mostly because of how massive this black hole is compared to the actual galaxy. And that's because Segue's stellar mass is only estimated to be approximately 30,000 solar masses, yet the black hole is 450,000, suggesting that the central black hole is at least 15 times more massive than all of the stars. But in most large galaxies, including the Milky Way, the mass of the black hole is usually completely dwarfed by the total stellar mass and barely makes any difference. And so here this is completely unexpected. But this is also a super exciting discovery, once again if confirmed, based on what scientists have been seeing coming from the James Webb, which is actually one of the potential explanations here. And so one of the explanations here is that maybe this is actually an ancient little red dot. You can learn about this particular mystery in some of the videos in the description, but basically in the last couple of years, James Webb has been finding a lot of these little red dot objects whose origin and whose actual nature is completely unknown. We have no idea what these are, but they seem to contain something very powerful and something compact in the middle, potentially some kind of a black hole. And here scientists have always wondered, so what happened to these objects and what did they actually evolve into? Did they become some kind of galaxies, quasars, regular galaxies or dwarf galaxies, or did they basically disperse completely, leaving nothing behind? And because all of them are characterized by having extremely massive black holes in the center and very small stellar populations, if Segue 1 is indeed a little red dot relic, it means that we finally discovered something super exciting right next to us. Here we have a nearby object that allows us to study processes from the early universe, entirely governed by the black hole growth and involving galactic formation in the universe's infancy. But that's of course a very big if. This is a really huge hypothesis and will take a lot of evidence to prove. Alternatively, this could also be some kind of a stripped remnant, essentially a part of a much larger galaxy that was slowly ripped apart as it passed closer and closer to the Milky Way, eventually getting completely destroyed by the tidal forces. And what was left behind is what we see now: a compact core, a few stars, and of course dark matter. So either way, whatever this galaxy is, it's definitely going to result in some exciting discoveries and will potentially teach us so much more about galactic formation and even maybe the universe itself. Here, if this is a central black hole, it was either a much larger galaxy or a mysterious little red dot, which actually would explain why a lot of these stars seem to be so ancient and so completely unevolved. And so this very chemically primitive galaxy is possibly one of the most exciting objects near the Milky Way. And that of course proves that even these very small, unassuming and barely visible galaxies can potentially hide some of the biggest mysteries in the entire universe. Now as always, this is just one of many studies, and this work on Segue 1 is going to continue for many years, but you can find the studies I mentioned today in the description below. So here I was making a video about the farthest galaxy ever discovered, the galaxy you see right here, when just a few hours ago from when I'm making this video, scientists release a new study. Looks like this is no longer a record holder. James Webb just beat its own record and discovered something that's even farther away and something that's even more mysterious. And by the way, this galaxy was also already quite mysterious because extremely recently scientists discovered oxygen in it. You can learn about this in one of the previous videos in the description. But now we have this, MOM Z14, a now confirmed new record holder that seems to be just a little bit farther away, but far enough to create new issues, new problems, and new exciting discoveries. And so, hello info person, this is Anton. Let's discuss this new record, discuss what it means for science, and talk about why this galaxy is apparently a little bit strange. And you can discover more about this in the study you see right here, a cosmic miracle, a remarkably luminous galaxy at redshift of 14.44, confirmed with the JWST. And I guess first, let's briefly discuss how this was discovered, because this is kind of important. And it was actually found here, the Cosmic Evolution Survey, also known as the Cosmic Survey, or the largest deep survey of the entire universe to date. This is actually made out of approximately 600 different Hubble images, all stitched together and all requiring approximately 1,000 hours of observations in the last few decades. But it only represents a tiny part of the entire night skies. As a matter of fact, we would require approximately 20,000 of these in order to cover the entire night skies. But over time, in this survey, researchers discovered a huge number of very distant galaxies, most of them as candidates, but some of them have already been confirmed. And one of these candidates was the galaxy we're discussing today. A galaxy initially picked up by Hubble, but a galaxy that was not confirmed until now. And that's because Hubble, as you know, does have its limitations. As a matter of fact, when it comes to the records from Hubble, we discussed it back in 2022. This was the famous JWST galaxy that was a record holder for just a few months, and that's until James Webb became operational and started to discover so many more. And since then, this galaxy dramatically dropped in its ranking, and you can kind of see how it compares to some of the other galaxies in this image. So basically, in just the last 3 years, because of James Webb, scientists were able to officially confirm several galaxies that were even farther away, and several galaxies that were even more exciting. Now, JWST is still kind of mysterious, and we actually discussed some of the recent discoveries in one of the videos in the description, but a lot of these new discoveries seem to be even better. And while this galaxy, JWST, lasted as number 1 for just a few months as well. And in this case, based on its redshift, we know that this galaxy existed approximately 290 million years following the Big Bang, with the other galaxy discussed in the same study, the one you see right here on the bottom, being slightly closer and existing approximately 10 million years afterwards. So basically here this was approximately 300 million years following the Big Bang. And so because so many of these galaxies were now confirmed, this kind of created a bit of an issue for modern cosmological ideas, especially when it comes to galactic formation. And though some scientists suggested that maybe our cosmology is incorrect, much more recent analysis suggested that it was actually the problem with simulations. As in, maybe we just didn't really push simulations far enough and ignored the idea behind tiny overdensities in the extremely early universe, because in some of the most recent studies, when these overdensities were considered, they suddenly started to create these early galaxies as well. So basically this was a problem with models, but not a problem that broke cosmology in any way. But there was one assumption that could have been incorrect. This is basically in regards to star formation. In most of these models, the assumption was that galaxies usually produce stars at a kind of a constant and somewhat unchanging rate, potentially increasing over time. But what we seem to observe is very different. Most galaxies seem to actually go through a kind of a burst, with rates of formation becoming really high temporarily, which causes many of these galaxies to become extremely bright, which would actually explain why we're seeing so many. But this doesn't last long, and the star formation eventually settles, just to potentially be restarted again, maybe following some kind of a collision or some kind of other powerful event. And in some cases, some of these emissions are also enhanced by supermassive black holes, which is also why we seem to observe so many different objects, including these mysterious little red dots. Once again, you can learn about this in one of the videos in the description. Over 300 have already been confirmed, and they're also kind of mysterious and are still poorly understood. But the fact that they exist means that something is definitely going on in the early universe that we still seem to have trouble explaining. Especially because many of these objects are just way too luminous and too bright compared to what's expected. Which is kind of what's happening this time again. We have this new discovery at a record redshift away from planet Earth, and it seems to contain certain parameters that don't make sense. And so let's discuss the discovery. Initially, it was detected because of this. As you can see here, it seems to be completely invisible in certain filters and only becomes visible in higher wavelengths. And that's because, like so many other distant galaxies, its light is blocked by neutral hydrogen. It's basically so far away that it's hidden from us by all of this gas that prevents some of the higher energy from getting through. And specifically, any wavelengths shorter than approximately 121 nanometers representing the Lyman alpha emissions, the emissions of hydrogen. And though normally this would be ultraviolet light, because of the expansion of the universe, by the time it gets to us, it becomes infrared light. But in this case, it doesn't really tell us the exact distance yet. It just gives us a rough estimate. And in order to discover the exact distance, researchers rely on additional observations, and specifically spectroscopic observations, from various elements we expect might exist here. And that's actually the lines you see in this image. Here we had nitrogen, carbon, and oxygen, and of course hydrogen and helium. And so by seeing these specific wavelengths, and by seeing how much they were redshifted, we can then determine the exact distance. And this tells us quite a lot. First of all, it tells us this galaxy is 33.8 billion light years away from us. Basically when the universe was only 282 million years old, or at a redshift of 14.44. But second of all, because we're seeing nitrogen, carbon, and oxygen, it tells us that there is a lot of star formation going on already. And of course, supernova. Or basically that for at least 10 million years, this galaxy has been creating new stars that were going supernova, producing huge amounts of ionization, with a lot of these ionized nitrogen, carbon, and oxygen atoms now visible in these emissions. And on top of this, we can also determine its overall size and mass. It seems to be about 500 light years across, so pretty small, obviously not a large galaxy, and also very compact. As a matter of fact, it seems to be extremely compact. Here the mass is approximately 100 million solar masses in a relatively small volume of space. This is actually discovered because light in this case seems to be extremely concentrated and not very diffuse. But something else was discovered that seems to be kind of unusual. First of all, this galaxy seems to be more or less dust-free. In other words, because of various emissions and because of potential supernova, it seems to have dramatically cleared itself of most of the interstellar gas. And second of all, there doesn't seem to be any indication for any black hole emissions. And that's actually kind of strange. In this case, in most of these galaxies, a typical supermassive black hole is going to inject a huge amount of energy into the accretion disk, thus increasing the overall brightness, making this object much brighter. But it would also make the ultraviolet light coming from this galaxy a lot less steep. And that's not what's seen from this galaxy, suggesting that the black hole is either very quiet or potentially non-existent, and thus presenting us with a new unusual case for a very compact and somewhat massive object that's once again somewhat difficult to explain and whose nature is currently unknown. As a matter of fact, because of the lack of black hole activity, it definitely confirms that all of this light seems to come from a lot of massive starburst activities. Or basically here, all of the stars started to suddenly being created, possibly within just the last 10 million years. And it was extremely high in the last 3 million years, kind of similar to what we usually observe in various molecular clouds, but obviously on a much larger, more massive scale. On top of this, this galaxy also seems to be very ionizing, or basically produces a lot of high energy light, which is seen as the emissions of nitrogen, oxygen, and carbon that's usually not as easily visible from other galaxies. And even though there's not a lot of dust in this galaxy, it seems to have a huge amount of gas, basically hydrogen and helium, possibly 20 times as high as in other galaxies at this distance, implying that this object is extremely dense and very compact. And right now this is maybe one mystery that's kind of difficult to explain. It's unclear why this galaxy is emitting so much energy and why so much of it seems to be extremely ionized emissions of nitrogen that we usually don't see from other galaxies. Likewise, it seems to be a little bit too massive and a little bit too compact. As a matter of fact, its overall mass is comparable to the Small Magellanic Cloud, but its size is much smaller, only 500 light years across. And for all we know, maybe this is actually a progenitor of some kind of a massive globular cluster, which are usually very compact, contain lots and lots of stars, and generally no central black hole. But that's just one of the potential assumptions, because the only thing we know for a fact is that this is definitely compact, very bright, seems to be forming lots of different stars, and there seems to be no black hole activity. And so maybe this is just what early galaxies were like, and this galaxy will just transform into something else as the universe evolves for billions of years. But there is actually something else that's mentioned in the study that also forms a new mystery. So far we seem to have two distinct populations of these very distant galaxies. Some of them seem to be large, extended, and produce somewhat weak ionizing radiation, but some of them seem to be very compact, very small, very massive, and produce large amounts of ionizing radiation visible as these powerful nitrogen emissions, with both types of galaxies discovered in a lot of these surveys. And it's this MOM-Z14 galaxy that seems to be the most extreme. And so here we have certain unanswered questions, and certain questions that need to be tackled in some of the future studies. Because for all we know, maybe the star formation in the first billion years was actually kind of different, and possibly the result of something exotic that we still don't understand. For example, some studies suggested that maybe this was the result of the same effects that produced the Hubble tension, or basically the evolving dark energy, or maybe something entirely different, which I'm sure we'll discuss in some of the future videos. And I'm sure we'll talk about this galaxy again very soon as well, except that I forgot to mention one thing. What exactly is MOM? Well, here this stands for Mirage or Miracle. This was the name of the initial survey that was designed to try to discover various luminous galaxies and find out if they're actually really far away or we're just producing some kind of an unusual effect, making them appear too bright. And it just so happens that in this case, this is indeed some kind of a miracle, or I guess a scientific miracle in a sense that it's kind of difficult to explain. It seems to be just a little bit too bright. Hello wonderful person, this is Anton, and in this video we're going to be exploring one of the most mysterious and I guess one of the most bizarre objects recently observed by the James Webb Space Telescope right here in the Milky Way galaxy. An object that's sort of like a planet, but that most likely used to be a star and over thousands and millions of years was physically stripped by its partner to become something entirely different. And so here, imagine a planet about the size of Jupiter, but with composition and atmosphere that's entirely different from anything we've ever seen. And in this particular case, based on the discoveries from the James Webb, it seems to be even more bizarre than scientists anticipated. And so let's discuss these new observations and these new discoveries from this very strange type of a planet known as the Black Widow pulsar planet. That's sort of surprising and sort of difficult to explain. But in order to understand why this object is so bizarre, let's I guess talk about how we think these are formed and what researchers previously assumed they might resemble. And so in a nutshell, it's what we would call a pulsar planet. A planetary object orbiting some kind of a pulsar or a neutron star, and the type of an object that, although kind of rare, is actually pretty well known to us because the first exoplanets ever confirmed were physically orbiting a pulsar and were discovered back in 1992. And all of this very likely starts with a massive star that runs out of fuel and eventually explodes in a brilliant supernova. Then what's left behind is often a very tiny super dense core, a core we refer to as a neutron star. And it just so happens that if this neutron star spins fast enough, it starts to produce radio emissions, kind of like a cosmic lighthouse. This is what we usually refer to as a pulsar. And what makes pulsars incredible for science is that they tend to produce incredibly accurate pulsations. They're basically some of the most precise clocks in the universe. And it was because of the deviations in these pulsations that 3 planets were discovered around a distant pulsar that currently has a proper name of LHC. And this was a huge deal because it proved that planets do exist outside of the solar system, and in this case can be detected by measuring these pulsations extremely accurately. And in the last few years, more such objects have been discovered, and we'll discuss some of them in the description below. But because pulsars are so small, actually seeing these planets would be extremely difficult. There will be practically no spectroscopy here, and it would be very difficult to observe any kind of emissions. But even though these are technically exotic and rare objects, researchers still want to understand exactly what they are, and more importantly, how they form or how they survive the supernova event. As a matter of fact, some of them are even thought to be diamond planets, or essentially the remnants of partner stars that were almost completely destroyed, but somehow survived the supernova, leaving behind a carbon-enriched core. But because a lot of their mass was stripped away, they essentially became planetary objects that used to be stars. But the object we're discussing today is slightly different, in a sense that it kind of started different, because it seemed to have a partner that was much closer. And so this object, referred to as PSR J2322-2650, was officially discovered back in 2017 in a study you see right here. But this was not just a pulsar, this was part of a much different, special system referred to as a Black Widow. A type of an object that's best described in this picture right here. In essence, it's a pulsar with a very close partner in an extremely tight orbit. And it's called a Black Widow, named after the famous spider, for a very similar reason. In these systems, the millisecond pulsar that orbits extremely close to the star first steals the mass from the star, accelerating its own spin, and then starts to use its emission to continuously strip the object, slowly destroying it in the process. And so basically it's eating its own partner and destroying it, just like the Black Widow spider. And so as this pulsar blasts the companion with intense high-energy radiation, usually involving gamma rays and very powerful X-rays, it slowly evaporates the companion star, making it smaller and smaller, and essentially turning it into a planet that even then starts losing its mass continuously. And this process is expected to strip away most of the companion's outer layers, most likely leaving behind some kind of a smaller, very often helium-dominated object. or at least that's what the scientists expect based on what we know about stars. And while today we know of 50 such objects, with most of them containing relatively massive and relatively dense partners with extremely hot day sides. And that's because the day side, or the side pointing toward the neutron star, is constantly illuminated and reaches temperatures in thousands of Kelvin. But something was a little bit different about this pulsar. It was also discovered to have a partner, or I guess you can call it a planet, but strangely enough here, the pulsar companion had a mass and density and even temperature somewhat similar to a typical hot Jupiter. A type of an exoplanet was discovered in a lot of different star systems that's usually almost the same as Jupiter, but just much hotter, which often results in the expanded atmosphere or in a planet losing a lot of mass. And so here too, the planet seems to have very similar density of about 1.8 gram per centimeter cube and the temperature of about 1900 Kelvin, which is lower than other similar objects and similar to a typical hot Jupiter. And so because of this uniqueness, this became a really intriguing target to observe with the James Webb Space Telescope. And so what exactly did JWST discover here? Now, as always, you can find the results and the study in the description below. But in essence, after observing this planet, while it orbited around the pulsar for 7.8 hours, it discovered something nobody expected. The atmosphere of this object seemed to be extremely enriched in carbon, specifically C3 and C2 molecules. Here we're talking about molecular carbon, which on Earth usually produces one of these combinations with hydrogen, such as for example propane. But in this case, they did not discover a lot of hydrogen, suggesting that most of this carbon was actually molecular. So things like tricarbon and bicarbon, which we often do find in outer space, but that has never really been seen on a planet. But more importantly, these C3 and C2 molecules, which mostly have been seen around tails of comets, or are even produced in flames and plasma right here on planet Earth, have never been seen in such a high abundance on any moon or any planetary atmosphere. And to really highlight how strange this is, researchers calculated the carbon to oxygen and carbon to nitrogen ratio in the atmosphere of this planet and compared this to planet Earth. And so in this bizarre case, the ratio of carbon to oxygen was approximately 100, which means that for every atom of oxygen, we would have 100 atoms of carbon. So obviously this could not be something like carbon dioxide that contains 2 oxygens and 1 carbon. Likewise, the ratio of carbon to nitrogen was exceeding 10,000 atoms, suggesting that this could not be molecules of, for example, cyanide or any similar molecules we might expect from some kind of a gas giant. And so the carbon-oxygen ratio was approximately 10,000 times higher than on Earth, with the carbon-nitrogen ratio being approximately 400 times higher, implying that this unusual planet was overwhelmingly carbon-rich, or at least its upper layers and its atmosphere. And though some signs of carbon-hydrogen bonds were seen, overall the hydrogen was present in very small amounts. They also discovered that when it came to surface temperature, the night side of the planet appeared somewhat featureless, possibly suggesting a very thick layer of dust or clouds, and possibly suggesting a huge cloud cover, maybe the result of this carbon haze, kind of similar to what Venus contains as well. In contrast, the day side basically just showed a lot of carbon molecule absorption spectra. And beyond the carbon chemistry, James Webb also provided insights about the planetary dynamics, including extremely strong westward winds, which were quite certainly the result of this planet being tidally locked. In essence, it's always facing the same side toward the pulsar, which forces very strong wind circulations going from the hot side to the cold side. And here researchers are pretty certain about this because the hottest part of the planet is not directly facing pulsar, which technically it should. Instead, it seems to be shifted by about 12 degrees, and in this case shifted to the west. And that's because of the very strong winds shifting the atmosphere just a little bit. But because in this case it's going westwards, this provides us with the first observational evidence for some kind of a new type of atmospheric circulation regime. And that's because previously it was predicted to go the other way, eastwards. As a matter of fact, the theory behind this predicts very fast rotation periods, but going in the opposite direction. And so here we have this new observation that seems to suggest winds on these planets potentially are produced in slightly different ways. But here it's also important to note that even though the planet's atmosphere is carbon-rich, the planet itself is most likely made out of helium. In other words, the interior structure is very likely dominated by helium, because if this was some kind of a carbon world, or I guess a diamond planet, given its mass, it would be much smaller in size and would be much more dense. But because of its density of 1.8 gram per centimeter cube, and because it's visible to the James Webb, meaning that its size is pretty large, this carbon enrichment seems to be just the surface feature, or possibly an atmospheric phenomenon, with the internal structure still being potentially similar to various gas giants. And so here these findings basically help us understand these black widow systems just a little bit better. Specifically, they might help us understand how the companions form, because according to previous predictions and previous models, the pulsar is supposed to strip the outer layers from the companion, leaving behind a core of helium, but also other diverse elements, such as for example oxygen and nitrogen. But by discovering that this object is extremely enriched in carbon and basically lacks everything else, this sort of creates a new puzzle in regards to how this was formed, or basically what kind of a star this used to be before it became a planet. Because once again, this used to be a star a long time ago, and it was through the process of pulsar stripping that this eventually became planetary in size. Here's actually a really cool image from the NASA's Chandra Observatory showing us how these objects look like from a distance. They actually do resemble these really massive comets. But the tail in this case is produced by the emissions from the planetary object. But when it comes to theoretical predictions or potential explanations, right now there is really none. For example, if this partner used to be some kind of a white dwarf, or a result of some kind of a merger between carbon stars, this still doesn't explain these ridiculously high carbon ratios. Because even carbon stars, which are usually enriched in carbon, do not show such extreme ratios of carbon to oxygen and carbon to nitrogen. And that means that for scientists studying these objects, they need new models, new predictions, new theories, and new explanations to try to understand why this atmosphere is so different, and how something like this could have formed in this ridiculously extreme environment. But the fact that scientists have also discovered signs of strong winds serves as an important confirmation for wind-based models, and for the fundamental understanding of how these extreme atmospheres seem to react when the object is so close to the parent star. But I guess when it comes to broader implications or why this matters, well, for one, we now have a completely new chemical way to conduct exoplanetary science. Mostly because, so far, these observations seem to be extremely different from anything we've seen around normal stars. And this obviously pushes the boundaries for our imagination and scientific understanding, while also highlighting how, well, strange and unusual the universe itself seems to be, and how we still have so many different bizarre discoveries to make, all of which require explanations sometimes in the future. And so here this very strange world seems to be somewhat contradictory. Its size, its density, and even its temperature and wind patterns more or less fit our modern models and align with current predictions. Yet its atmosphere, or whatever is happening on its surface, seems to be an entirely different story and currently makes no sense. And it's really these kinds of anomalies that normally drive scientific progress. They force us to rethink our previous assumptions and force us to explore completely new possibilities. In the last 3 years, there's been quite a lot of somewhat bizarre discoveries coming out of James Webb Space Telescope. Discoveries that nobody expected, discoveries that are somewhat difficult to explain even today, and of course discoveries that kind of redefine our understanding of the entire universe. But one of the strangest discoveries that we're still having trouble explaining is right here. This is referred to as a little red dot. Hundreds of very strange objects discovered by the James Webb, only visible to the James Webb, whose origin is still not entirely clear. You can actually explore some of these previous explanations in the videos in the description, but today we're going to discuss a relatively new discovery that maybe, just maybe, takes us a little bit closer to actually understanding what's happening here, and possibly finds a missing link. But in order to connect all of these events, and in order to help you understand why this is important, let's actually talk about something that happened almost 7 decades ago, when radio astronomy was just starting. And this was sometimes in the 1950s. Back then, some of the first radio dishes became operational and essentially started to observe the universe with radio light, allowing scientists to finally see through everything, because radio light generally goes through all of the gas and all of the dust that usually blocks optical emissions. And though at first they started to discover a bunch of galaxies and a bunch of never-before-seen stars, they also started to discover a few anomalous objects. And here's actually a picture of one of them, 3C273. This somewhat bizarre star made absolutely no sense. at least back then. And it actually made no sense, and to some extent even broke physics, physical models for several reasons. First of all, this object was emitting a lot of radiation in a lot of different frequencies, which was kind of difficult to explain. Yet when the researchers tried to look at this with the optical telescope, there was basically absolutely nothing. It wasn't producing any optical emissions, or at least nothing that was easily visible. And though one of these objects did actually contain a very dim point, even here the observations were somewhat mysterious. And especially mysterious because of the observations of the spectral lines. Here this concept refers to the very specific wavelengths that are usually emitted by certain elements, or certain molecules. For example, the famous 21 centimeter wavelength refers to the hydrogen line. But these strange objects, which were now discovered by the dozen, all seem to contain very bizarre spectral lines of essentially elements or molecules nobody could explain back then. In many cases, these were wavelengths that were just extremely different from anything that was predicted. And so here this created a major mystery, a mystery of somewhat bizarre stars that all kind of resembled this, but stars with very strange, very powerful emissions containing unusual chemical elements and a few other anomalies. For example, quite a few of them dramatically and rapidly changed their luminosity, especially in the X-rays. Or basically they were blinking and changing the amount of emissions like no other star we've ever seen. Moreover, when researchers used what's known as interferometry, or essentially used various telescopes to try to measure their overall size, they also realized that these objects are kind of small. The limit on their size was no larger than the entire solar system, so basically less than 1 light year across. Yet despite of this, they seem to contain extremely high power density and emissions that we've never seen from any star anywhere, which is why researchers in the 50s and in the 60s started to refer to these as QSO, quasi-stellar object. Kind of like a star, but not really a star. And by 1960, hundreds and hundreds of such objects have already been recorded and published, yet there was still no explanation. And it was actually only in 1963 that at least one of these objects was finally linked to some kind of a relatively dim blue star, but once again containing a lot of strange emissions of molecules or elements that nobody could explain. It's as if they actually contain entirely different chemistry, not carbon, not oxygen, not hydrogen, but actually elements we've never seen anywhere on Earth. And it was the observations of this anomalous spectrum that created the biggest problem. How could there be stars containing elements or compounds or molecules we've never seen anywhere? But then, within just a few years, researchers finally cracked the mystery, because here these wavelengths appear to be redshifted. Here the object known as 3C273 seemed to contain hydrogen wavelengths that were redshifted by 15.8%. And it appeared that quite a lot of other wavelengths were redshifted by the same amount, with similar discoveries suddenly made in a lot of these other QSOs, and in some cases redshifts were really high. But the only way this would make sense is actually if these objects were moving super fast. For this object it had to be 47,000 kilometers per second. And so if this was a physical motion of a star in our galaxy, this basically made no sense because our galaxy is not big enough for the star to travel for such a long time, which meant that the only possible explanation for these objects was their distance. Maybe these were super far away from us and moving away from us at very high velocities, while also producing ridiculous amounts of energies, so they could be detected from very far distances. As a matter of fact, this object was even discovered in ancient photographs going back to 1900s, and it was in exactly the same location, which actually suggested that it hasn't moved across the galaxy at all. It must have been super far away, which for astronomers in the 1960s created a new mystery. What exactly could produce such enormous powers? Here we're talking about an object very far away, moving super fast away from us, and an object that's only 1 light years across. Much smaller than a typical galaxy. And it was really only in 1964 that some of the initial propositions started to be made. This was actually made completely independently by researchers studying hypothetical black holes and what they can actually produce, with the Soviet Yakov Zidovich, whose study we recently discussed in one of the videos in the description, that made a proposition involving massive black holes, potentially forming what's known as an accretion disk, where a lot of inflowing matter can start producing ridiculously powerful emissions. Intriguingly, at first, this idea was basically rejected by most astronomers because back then black holes were extremely hypothetical. But study after study, things started to make sense. And within about 20 years after their initial discovery, by 1970s, several independent studies and various pieces of evidence started to explain this somewhat bizarre mystery. First, all of these observations confirmed that these objects are super far away and super small. There was also confirmation that all of them were moving away from us at very high velocities, up to 100,000 kilometers per second, basically 1/3 of the speed of light, which surprisingly served as a major confirmation for the Big Bang theory that was actually being debated at this point, and the idea behind the expansion of the universe and the Hubble's law. As a matter of fact, it was these quasars that finally provided needed visual evidence. And so if this redshift was due to the expansion of the universe, and these objects were super far away and very bright, the only thing that had enough power to produce all of this energy had to be the hypothetical supermassive black hole, because a distant, extremely powerful object was the only possible explanation that aligned with all of the evidence. This could not be a small star just because it was moving way too fast. And so sometimes in mid-1970s, this officially established the idea behind quasars, with additional explanations eventually establishing that it was really the angle of observations that made certain of these quasars and other similar objects somewhat different. And so all of this was the result of the very powerful jet and the very powerful accretion disk. And if we're looking directly at the jet, we're seeing a blazar. If we're looking a little bit away from it, we're usually observing one of these quasars, and if we're seeing it from the side, it seems to appear as some kind of a Seyfert-2 galaxy or a radio galaxy. So massive black holes, viewing angle, and expanding universe suddenly explained everything we know about the universe. And well, as of today, nearly 1 million quasars is known to us, with pretty much all of them exhibiting extremely similar patterns, with pretty much all of them showing us very similar properties and exhibiting very similar patterns. And although this mystery took over 20 years to solve, because of the new observations from the James Webb, we're now faced with new mysteries, kind of similar to those first observations of quasars back in the 50s. And that's of course the discovery of these little red dots and a lot of other similar objects. Here, these objects also seem to be relatively small, extremely compact, but in many cases actually seem to possess properties different from what we expect from a quasar. Once again, some of the videos in the description discuss this mystery in a bit more detail. But in a nutshell, James Webb discovered a bunch of these AGNs, or active galactic nuclei, that we now refer to as little red dots. And the name here explains everything. They're small, they're red, and they only seem to be visible to the James Webb, or basically only visible in the infrared. No other telescope has ever seen these before. But compared to a classical quasar, they're actually even smaller, dimmer, and most importantly, hidden by a lot of dust. This is not what we usually observe around quasars. And because of this bizarre mystery, scientists in the last few years have been trying to figure out if this is somehow connected to quasars and maybe evolves into them, or if this is an entirely different object that possibly becomes something entirely different in the modern universe. As a matter of fact, as of today, nobody has any idea what exactly this is and what it becomes. It could be some kind of a star cluster, it could be some kind of a growing supermassive black hole, or it could be something entirely different. But in order to solve this mystery, we needed new observations and new potential links. Some kind of a connection between two different types of AGNs that possibly have some properties from both quasars, galaxies, star clusters, or something else. And well, looks like now we potentially have some examples that could start answering some of these questions. A new hidden population of unusual objects that once again have never really been seen before and are currently referred to as SHELLQs, Subaru High Redshift Exploration of Low Luminosity Quasars, which in this case, as the name suggests, was actually discovered by the Japanese Subaru telescope. And here this telescope initially discovered them as barely visible blobs located in the early universe approximately 1 billion years after the Big Bang. And what made these galaxies somewhat unusual is the fact that they didn't really resemble typical quasars, but their intensity of light was way too high to be coming from the star formation alone. So essentially here something else was causing these objects to be way too bright. But unfortunately Subaru was not powerful enough to establish exactly what the light was coming from. However, it was assumed to be a supermassive black hole. And it was the observations from James Webb that finally allowed the scientists to see what's happening here, reanalyzing these objects once again and confirming the initial assumptions. Here, scientists definitively confirmed the presence of gas that was moving under the influence of an extremely massive, compact object, a supermassive black hole. So these were definitely confirmed to be AGNs, active galactic nuclei, but a type of AGNs we've never seen before. Out of 13 of these distant galaxies, 9 displayed very clear signs of active supermassive black holes, and more importantly, the pattern of light produced inside of these objects was extremely similar to much older quasars, but quasars that were actually hidden by dust. In other words, it actually suggested that these objects are baby quasars, or at least quasars that seem to be hidden by a dust cloud. Objects that appear to be just as bright as quasars, but with levels of dust we actually observe in a lot of these other objects, such as little red dots, which to the scientists behind this paper implied maybe two things. First of all, this could be that connection we needed to possibly explain little red dots. Maybe at least some of them do become quasars, and maybe this is what quasars initially started as. But second of all, this also suggested that many of these quasars are still hidden from us, or to be more exact, a lot of these active supermassive black holes have been overlooked because many of them seem to contain these massive dust clouds. And so technically there should be even more quasars out there, but a lot of them are just hidden and are only visible in certain wavelengths. And so the overall conclusion from the study is that there seem to be a lot of these obscured quasars in the early universe, with many more still missing and many more still hiding. With the second conclusion potentially being that this could be a direct link to the little red dots. But this can only be confirmed with future observations, which are planned for the next few months. But more importantly, hoping to find very similar signs or very similar properties in at least some of these little red dots as well. Because here, by connecting baby quasars with little red dots, we can potentially find clues uncovering how some of these objects evolved into each other. But since this is only based on a handful of objects, these SHELLQ objects, we're not going to know more until future observations. As a matter of fact, for all we know, maybe these SHELLQs are entirely different, completely independent of both little red dots and quasars, and maybe they actually do end up producing something entirely different. And so until more observations with the James Webb and additional studies, we're not going to know much more. Because for now it really looks like being back in the 1950s. We have a lot of these really bizarre discoveries nobody can explain, a lot of these observations that make no sense, and it's quite likely that in the next decade or so, our entire understanding of the universe will change completely as a result, just like it did in that era of 1950s to 1970s. I mean, this is the time when we confirmed the Big Bang Theory, but for all we know, these new observations might reveal something entirely different and something even more surprising. Hello in full person, this is Anton, and well, looks like it's another day and another bizarre galaxy discovered by the James Webb that once again makes no sense, or at least is very difficult to explain based on modern cosmological theories. And in this case we're talking about this galaxy, a tiny red dot super far away that seems to be producing emissions it should not be producing. And so let's talk about this discovery in a little bit more detail, talking about the mystery and potential resolutions. But I guess first of all, what exactly is this galaxy and where is it located? Well, like so many other unusual galaxies discovered by the James Webb, this one is also from the famous survey known as JWST Advanced Deep Extragalactic Survey that's already discovered so many strange galaxies, including some of the biggest record holders. And in some of the recent videos in the description, we've talked about some of the biggest discoveries, and actually some that also didn't really make much sense, such as the discovery from the most distant galaxy that seems to contain a lot of metallic elements, including things like oxygen, which nobody thought would be there. But this galaxy, JWST-13-1, is a little bit closer. It's still about 33 billion light years away from us, but in terms of when it existed, the picture from the most distant galaxy is coming from the universe that's only about 294 million years old, whereas here the universe is about 330 million years old, so approximately 35 million years difference. Technically though, this is basically the same period. But more importantly, this is basically the end of these so-called dark ages, the beginning of reionization. And so in order to understand this discovery, we actually do have to discuss the dark ages a little bit more and talk about this reionization. Now, in case you're familiar with this, you can use that skippy thingy below me and go to the next part. But let's briefly talk about the dark ages. The universe suddenly cooled down, and a lot of super hot plasma recombined into actual atoms and formed some of the first gas, mostly containing hydrogen, helium, and a little bit of lithium. And this is of course when we start seeing this first light, cosmic microwave background. And well, for the next 200 million years or so, it's always been believed that the universe basically remained more or less dark and filled with a lot of neutral hydrogen. Or basically hydrogen that was not ionized, but also hydrogen that usually absorbs a lot of high energy light. For example, UV light or even gamma rays and X-rays don't actually go through this gas, and instead by interacting with it, they ionize hydrogen and get absorbed in the process, which as a result created a bit of a problem for modern cosmology. Some of the earliest and some of the most powerful light, which very likely produced UV radiation, and of course a lot of X-rays from things like black holes, is technically invisible to us. So during the dark ages and during the early period of reionization, a lot of these high energy photons basically got absorbed by something, which made the universe opaque in a lot of high energy observations. And we actually have so much evidence about this period from a lot of these distant galaxies. As a matter of fact, there's even an entire type of galaxies known to us whose light usually tells us that they're really far away and seem to be located inside this neutral gas. And the most famous type is known as Lyman break galaxy. Galaxies that can only produce light that's less than 912 angstrom in wavelength. Or galaxies whose spectrum will always have this bizarre break. And it's called Lyman break because it's related to Lyman limit and the Lyman series, which is basically hydrogen emission lines that looks something like this. These are hydrogen spectral series resulting from the UV emission lines of hydrogen when the electron goes from one energy level to another. And this is essentially a telltale sign that something seems to be blocking a lot of this high energy light coming from these galaxies, with that something always being predicted to be this neutral hydrogen. But as more and more stars and as more and more galaxies became active, they very slowly reionized the entire universe, which slowly transformed all of the neutral hydrogen in the universe into ionized hydrogen, making the universe once again transparent. But because a lot of this is still based on a lot of predictions and a lot of theories, one of the main missions for the James Webb was to basically understand how and when this happened, how long it lasted, and of course, what actually caused the reionization. And this reionization period was previously discussed in a video in the description, because scientists now believe they know what actually did it, in this case, very powerful dwarf galaxies, but the timeline and some of the additional anomalies still don't really make sense. And in this case, we now have another anomaly that's difficult to explain, this little red dot. And this is an anomaly for so many reasons. First of all, here researchers don't even know exactly what this is. Little red dots have been discovered before, and once again, a video in the description talks about them more. But here, unlike previous detections, and unlike previous galaxies and even previous distant black holes, the spectroscopic analysis revealed something that definitely stands out. We get Lyman alpha emission. Not a drop-off, not a break, but an actual emission from something super powerful producing UV light, which at these distances should not be visible. Once again, all of the previous detections, even from much closer galaxies, always have a drop-off or a break. Or basically, in certain UV frequencies, these distant galaxies should be completely invisible. But not this one. Wherever this red dot is, it's super visible and super bright, and produces a telltale sign of the Lyman alpha emission that has never been seen so far away, with some of the galaxies that appear so much similar only seen at much closer redshifts. Here the redshift is usually less than 9. But even in these cases, the Lyman alpha was never this bright. And moreover, the nature of this galaxy is also currently difficult to explain, because here this is something super compact and something very powerful, and something that's obviously producing huge amounts of radiation. Now obviously this could be a very large population of super hot massive stars, or possibly even population 3 stars, the first stars in the universe. It could also be a powerful central black hole, or a combination of both. And so whatever this is, we've never seen anything like this before. For example, if this is a central black hole, this would be the most distant supermassive black hole we've ever seen. And here, depending on its mass, it would potentially create some other problems for some of the explanations in regards to black hole evolution. Whereas if this is just stars, it's not clear why these stars seem to produce and seem to even leak so many ionizing photons that seem to be invisible in every other galaxy. And so for some unknown reason, somehow this galaxy seems to be shining through this neutral hydrogen fog, ignoring a lot of previous assumptions we had about the early universe. Now once again, this is only 330 million years old, or basically one of the earliest galaxies we've ever seen, and it's definitely located right at the start of this reionization period. Now here the mystery could be resolved if this was much closer to us, or in much older universe, but this recent study definitively confirms the redshift. And this was actually achieved by measuring this Lyman alpha emission, and by confirming the redshift to be 13.05. In other words, the distance to this galaxy was actually confirmed by detecting this super powerful light from ionized hydrogen. But at the same time, we actually still see signs of some absorption, suggesting that this was indeed during the cosmic reionization period. And so in that sense, it does not break theories of reionization, it just seems to be some kind of a really bizarre anomaly. This super powerful ultraviolet light currently just cannot be explained. But nevertheless, researchers do provide some potential explanations. Here they basically think that this galaxy, or whatever this object is, created a kind of a massive bubble around itself that seems to be already entirely ionized. It's about 200,000 light years across, or about twice as big as the Milky Way galaxy, with this very early re-ionized region possibly preventing extinction of this Lyman alpha radiation and thus allowing it to pass through to eventually reach our planet. But in order to produce such a huge bubble, and in order to reionize everything around itself, it has to be an extreme galaxy, either containing a super powerful active galactic nucleus or a black hole, or once again containing an enormous amount of very powerful massive stars. Something that's also kind of difficult to explain because this is only 330 million years after the Big Bang. And so in this case, the biggest mystery is actually what exactly is causing all of this radiation and what's producing this super bright emission. Here the source of this Lyman alpha radiation and the source of this massive bubble is completely unknown. In fact, it might be some kind of a peculiar phenomenon, or maybe even some strange form of stars that were predicted in some of the previous studies but have never been found until now. And we'll actually discuss some of this in some of the future videos once we get some updates about this discovery and once there are some additional observations figuring out how this is possible. Either way, whatever this is, it seems to be much hotter, more luminous, and more powerful than anything we've seen at this early stage. And because it's so tiny and so compact, we don't really know what it is. Hello wonderful person, this is Anton, and today we're going to be discussing some of the most recent discoveries in regards to the mysterious concept known as population 3 stars, or essentially the first mysterious stars in the universe that most likely served as the foundation for all of the other molecules in the first few millions of years, and eventually produced all of the stars and all of the planets that we have around us. And so today we're going to discuss a very exciting discovery of a never-before-seen galaxy that seems to suggest we may have found them, or at least see signs of something similar to these stars in this particular location. But first, I guess let's start with some of the initial concepts just so that it all makes sense, and just so that you understand how important this discovery is, assuming of course it's confirmed. Now first, we're all familiar with the idea of elements, but in astronomy, elements heavier than hydrogen and helium can only be forged inside stars in the process known as stellar nucleosynthesis. And so here it might help you to kind of stop for a second and consider this fact. Every single element you interact with daily, from the oxygen you breathe to the iron in your blood, had to be created by stars that lived and died billions of years ago. And this is actually something I think about when I'm kind of depressed or sad, and it kind of gets me back into the normal mode. But how exactly did this process start initially? Well, today we believe it all started with these first stars referred to as population 3 stars. The ones that had nothing to work with except for pristine hydrogen and helium produced once the universe cooled down enough following the Big Bang. And according to cosmological models, the early universe was approximately 75% hydrogen and about 25% helium, with maybe trace amounts of lithium and beryllium as well. And the stars that formed from this pure cosmic soup are known as the population 3 stars. This is essentially a classification that we've had for a very long time, with the population 2 stars being a little bit younger and produced following the explosion of these first stars, and the much younger, more advanced population 1 stars like our Sun being formed in just the last few billions of years. But for many decades, these stars were entirely hypothetical. They represented the onset of cosmic structure and chemical enrichment, but were practically impossible to find for many different reasons. For example, the distance in this case would be absolutely incredible, because we think these stars existed only in the beginning of the universe, and at the same time they very likely only existed for maybe 2 or 3 million years. And so trying to find the exact moment when they all existed so far has been incredibly difficult. But we now have the telescope designed specifically for this, James Webb. And based on some of the recent observations of this very tiny distant galaxy known as LAP1-b, researchers potentially discovered some of the most compelling candidates yet. With this potential discovery, if confirmed, basically rewriting our understanding of how stars and galaxies form, and teaching us just a little bit more about the universe. But I guess once again, so what exactly is the difference between these stars, and why are population 3 stars so important? Well, here this is in regards to the concept known as metallicity. And in astronomy, this is just a fancy word for the abundance of elements that are not hydrogen and not helium. So for example, the Sun is a star that's high in metallicity because it contains a lot of stuff that's not hydrogen and helium. And that's because the Sun is relatively young and enriched in metals. But older stars, especially population 2 or these hypothetical population 3 stars, are extremely poor in metals. And we actually see a lot of this by looking in the halo of our own galaxy. Some of the stars we've discovered are up to about 12 to 13 billion years old, and for the most part they only contain hydrogen and helium with just a trace amount of elements. You can learn about some of these discoveries in some of the previous videos in the description. But when it comes to population 3 stars, they essentially stand alone. They are the first generation, formed before anything else existed, and before there was anything except for hydrogen and helium. And all of the stuff they formed from has never been recycled or used for anything else. And so because of this lack of metals, or lack of anything more advanced than hydrogen and helium, it would probably affect their structure. But here this is where we basically have to rely on theoretical predictions and assumptions. And some of these early theories suggested that because they couldn't cool effectively, a lot of these population 3 stars must have been behemoths, potentially hundreds if not thousands times the mass of our Sun and tremendously huge in size. But because of this mass, they would also have incredibly short lifespans, maybe 2 to 5 million years maximum. And this would all end with some kind of an ultra-powerful explosion, or maybe a direct collapse into black holes. And so this very rapid demise of many of these stars explains why they are so extremely difficult to find today, because for each individual galaxy we would actually have to find a super tiny time frame when some of these stars potentially existed. And so the only chance to observe them is to look at extremely distant galaxies whose light originated during some of the earliest periods of the universe. And well, LAP1-b is one of these crucial extremely distant systems discovered extremely recently. And here this is an ultra-faint dwarf galaxy located at a redshift of 6.6, or when the universe was only about 800 million years old. But importantly, because this is a dwarf galaxy, we know that it just started forming, and it's intrinsically extremely faint. As a matter of fact, it would be naturally invisible to us if it wasn't for one little quirk. Here it just so happens to be inside a gravitational lens. You can actually see it in this image. And this gravitational lensing magnified the light from this background object so much that it now appears to be at least 98 times larger. So once again, this is just a super lucky observation. And so here, by using the James Webb and by analyzing the light from this galaxy, in 2 studies you can find in the description, scientists did actually discover something super exciting. Here we had several key pieces of evidence suggesting the presence of these population 3 stars. Okay, so what exactly are they? First, extreme chemical primitiveness. When looking at this galaxy, it seems to be the most chemically primitive star-forming galaxy ever seen. And this is out of hundreds and hundreds seen so far from the James Webb and other telescopes. For example, here its oxygen abundance is less than 1% of the solar value, suggesting that the interstellar gas has been enriched by only a very small number of stellar generations. Or basically this galaxy only experienced a very small number of supernova. Then there's also hard ionizing spectrum. This galaxy exhibits an exceptionally powerful ionizing radiation with something emitting high energy photons. And this type of radiation is inconsistent with your typical metal-enriched stars or population 2 stars or even black holes. but surprisingly is almost a direct confirmation from theoretical predictions for the emissions of population 3 stars. Or just to rephrase this, the very powerful radiation coming from this galaxy seems to be consistent with the models for zero metallicity massive stars. The UV light that they seem to form is almost exactly a match. Likewise, there's an elevated carbon to oxygen ratio that's approximately 1 to 2 times the solar value, despite the extremely low metallicity, and this elevated CO ratio is predicted as a typical chemical signature of population 3 stars. Specifically, it seems to match models where population 3 stars explode as a very faint supernova. And so in these types of scenarios, the initial explosion is kind of weak, preventing the ejection of the inner oxygen-rich layer, which then collapses into a black hole, and the carbon-rich outer layer is expelled, enriching the surrounding gas with carbon. And this is right now the first object ever to consistently agree with the 3 key theoretical predictions proposed by previous studies, with the theoretical modeling suggesting that finding such an object, especially using these highly magnified observations through the gravitational lensing, is statistically expected at this exact redshift. Or just to rephrase this, in terms of statistical probability, this is exactly what we expect to see and when we expect to see it as well. And this object even supports the predictions for the initial mass function, with the emission lines so far being entirely consistent with the presence of these massive population 3 stars, and specifically massive stars formed inside these low mass clusters. But interestingly, so far the data from JWST shows us that the total stellar mass is surprisingly low, less than 2,700 solar masses in total. As a matter of fact, the calculations based on the observed light suggest that the cluster here contains roughly around 1,000 solar masses of population 3 stars, aligning with the prediction of small clusters and either one or several stars, approximately 1,000 solar masses in total. And by the way, all of this was reported in 2 separate studies from 2 separate teams, whose research you can find in the description below. So this is definitely a super exciting discovery, because in this case, 2 separate teams seem to have come to the same conclusion. But here there was still a somewhat interesting point of contention, and specifically in regards to the galactic mass. When analyzing the galactic kinematics, or basically looking at how gas is moving around the galaxy, researchers discovered a very broad hydrogen line suggesting a very high velocity of dispersion of approximately 58 km per second. And this would suggest something really massive in the center, with a mass of about 10 million solar masses. And so if everything here was driven by gravity, it would suggest the galaxy is embedded in an extremely massive dark matter halo, which would be very difficult to explain. However, this dynamical mass is over 100 times higher than the combined mass of all of the stars in this galaxy, which, as I mentioned, is less than 3,000 solar masses. And even though there might be about 10,000 solar masses of gas, this is still just a little bit too massive based on modern theories. And so this huge gap between observed matter and invisible matter suggests that the system is either extremely dark matter dominated, or is basically inside some kind of a massive chunk of dark matter, or there is something else entirely different going on here, and something that currently does not make sense. Now obviously one explanation could be some kind of a central black hole, but no emissions resembling a black hole seem to be visible. But scientists do offer at least one alternative explanation. This very broad hydrogen line might not be due to gravitational orbital motion, but instead some kind of a very fast gas outflow that's actually driven by intense radiation and intense stellar winds coming from these extremely powerful population 3 stars. Or in other words, the fact that we see something moving so fast is not really because it's spinning around something, but because it's leaving the galaxy, with the velocities predicted by simulations once again being consistent with the observed line width, and once again supporting the idea that this galaxy seems to be hosted by theoretically small and somewhat cold atomic halo that seems to have a few of these massive stars inside of it that are driving all of this expansion. And so right now, based on all of the observations, the discovery of this LEP-1b galaxy seems to align with a lot of theoretical predictions on the population 3 stars and on what we should be finding somewhere out there. And while population 3 stars were traditionally thought to be enormous, some of the new computer simulations have also challenged this idea as well. As a matter of fact, some of these simulations discovered that very strong and very powerful turbulence around these stars seems to develop inside of these molecular halos and produces very turbulent and very violent winds, sometimes up to 5 times higher than the speed of sound inside of this gas. And this massive turbulence efficiently stirs and compresses the gas, causing the primordial star-forming cloud to fragment into multiple clumps. And so in these types of situations, it would most likely produce less massive population tree stars, anywhere from 1 to 40 solar masses in total, instead of hundreds or thousands of masses. But because this is so super far away, it's going to be very difficult to tell if this is just a few really massive stars, or if it's hundreds of small stars appearing as one. Nevertheless, the properties from this galaxy do actually suggest an evolutionary connection to a population of galaxies we even see today, the ultra-faint dwarf galaxies. Ancient stellar relics that we discovered in the local universe that are mysterious in their own right. And so this galaxy's low mass and extremely low metallicity, dominated by dark matter, and even the elevated carbon to oxygen ratio seem to actually match characteristics of some of the nearby UFDs, which implies that this galaxy is possibly something that's going to one day become an UFD. A low-mass galaxy captured when it was still actively forming stars, but that one day is going to become extremely quiet and almost completely lack any stars, becoming dominated by dark matter. And we actually discussed one of such galaxies extremely recently in one of the videos in the description. And so observing this galaxy gives us a rare window into a lot of mysteries of astronomy. Because here we potentially have observations of the first stars, but also mysterious galaxies we discovered not so far away from us. And so assuming this is confirmed in the next few months, this is going to be a landmark achievement. Mostly because it provides spectral evidence for the existence of these first stars, and officially proves the existence of these zero metallicity stellar populations that were predicted by various models. But naturally this was not an accidental discovery. Obviously the gravitational lens was accidental, but the James Webb was specifically designed to find these stars. It was actually one of its primary missions. And so finding these primordial systems was exactly what James Webb was made for. And this is a really important study for cosmology. It essentially provides us with a very important link between the post-Big Bang universe, with basically no stars and just a lot of primordial matter, and the chemically enriched cosmos we inhabit today. In the last couple of years, one of the most incredible discoveries coming out of James Webb Space Telescope was essentially this. A collection of very strange, very distant objects that seemed to exist in the universe when it was only about 300 million years old or even younger. Strange red objects representing some of the most distant objects we have ever seen. And that's because a lot of these objects are extremely redshifted and are only visible in the infrared light, which is of course what the James Webb was built to see. But so far, most studies assume that these were basically baby galaxies, or essentially proto-galaxies, or maybe massive early star clusters that seem to have formed in an extremely early universe. Except that in April of 2023, we've discussed a really interesting alternative explanation. Maybe, at least some of these objects, especially the ones that appear to be very compact, and the ones resembling a point source, could only be explained if these were actually very exotic dark stars. A concept we've discussed previously, but a concept that I wanted to briefly discuss once again, just so that all of this makes sense. And that's because extremely recently, Catherine Fries and the team you see right here released an additional study that actually provides even more evidence that maybe this is something super exotic. And so let's talk about this study and the explanation in a bit more detail, and discuss if this is indeed supermassive dark star candidates. But first briefly about the idea of dark stars. Now historically, this concept of dark stars has been proposed a long time ago. As a matter of fact, as far back as 1783, when early astronomy was still being developed. The original dark star concept was by John Michell, who discussed this concept with Henry Cavendish, and then published this in a letter to the Royal Society in 1784. That's literally 250 years ago. But here he was talking about dark stars that would be actually kind of similar to black holes. Stars so large and so massive that they would basically trap all light because of the surface escape velocity. And while based on modern theories, we know that something like this would most likely just become a black hole. But over the years, scientists have also developed a separate idea once researchers realized that there seems to be a lot of additional stuff in the universe that we could not explain. For example, dark matter. And so the explanations for dark matter that essentially involve some kind of a particle suggested that sometimes some of this dark matter can become extremely dense and collapse into some kind of a cloud-like object that starts to attract a lot of hydrogen and a lot of helium. In essence, this is actually how today we explain the existence for various galaxies. As a lot of dark matter accumulated into larger and larger chunks, it started to attract hydrogen and helium that eventually started to coalesce into larger objects, formed some of the first star clusters, and basically created early galaxies. But in some rare cases, some of these dark matter particles might also create their own individual objects, with even a little bit of dark matter potentially creating large enough clouds of hydrogen and helium that they start to form individual, massive, compact objects. And though in a typical star, normally the energy is produced as a result of fusion, which is when hydrogen combines into helium and releases energy, inside of these bizarre dark matter objects, they start to be powered by something entirely different. Tiny dark matter particles start to bump into each other, start to annihilate, and essentially result in the production of energy as well, releasing a tremendous amount of heat that then starts to heat up hydrogen and helium inside the cloud. And so this is what a lot of dark matter researchers refer to as dark matter stars or dark stars. These would be enormous clouds of hydrogen and helium as large as 1,000 astronomical units across, or essentially 50 times as large as the orbit of Pluto, that because of this dark matter annihilation produce extremely hot objects with the surface temperature for this hydrogen reaching 10,000 Kelvin, kind of resembling these very massive O-type stars, but also very massive overall, over 100 solar masses in mass. And as these objects accumulate more and more mass, they do start to grow larger and larger, but at some point, once a lot of dark matter has been annihilated, and these stars no longer produce enough heat and enough energy to sustain themselves, they potentially suddenly collapse, resulting in a very massive, dense object. And with some of the most massive clouds, potentially thousands or even millions of solar masses, we get a supermassive black hole. And so some of these objects that can become very large and very massive eventually result in extremely massive central black holes, around which we expect a galaxy to form. And so this is actually one of the potential explanations for the existence of supermassive black holes, especially the ones too massive to exist. But naturally, this was just a hypothesis and just one of the explanations. We didn't really have any evidence. As a matter of fact, up until James Webb, there's only been some circumstantial evidence of dark matter stars, and mostly based on observations of gravitational waves and potential collisions of smaller objects. Yet, as I mentioned, in 2023, at least one study that you can learn more about in one of the videos in the description suggested that some of the observations from the James Webb were actually consistent with being point source dark matter stars, because it's the only way we could explain their brightness, the only way we could explain why they existed so early on, and of course explain why they were so tiny and appeared star-like, with the initial spectral analysis of some of these objects suggesting they were between 500,000 and 1 million solar masses, with luminosity of billions of suns and a radius of at least 10,000 stars, which is of course much larger than any star in the modern universe. And though some studies propose that these are just very unusual baby galaxies, or maybe even giant black holes covered by a lot of dust, these explanations sort of created even more mysteries. If these were giant black holes, how exactly did they form so early? And if these were active stars, once again, why did they form so early? And why there are so many of them in such a small space? So basically here, no matter what explanation scientists proposed, there was always something that was missing. However, the dark matter star hypothesis originally suggested that such objects could actually exist as early as 200 million years following the Big Bang. So basically these dark matter stars could easily exist in the early universe and would mostly be made out of hydrogen and helium, orbiting around a central point made up out of a lot of dark matter particles. But following this initial proposition in 2023, we didn't really have any new updates or any new suggestions, and that's until now. In this recent paper, researchers looked at some of these objects even closer, but this time decided to focus on something else. They used the James Webb's ability to analyze colors of light, here we're talking about spectroscopy, in order to find out what these objects were made out of and how they're powered. And here the focus was on some of the most distant objects discovered, such as the ones that used to be record holders. These objects existed just under 300 million years following the Big Bang. And they also wanted to check the shape of these objects based on the pictures we have, because if these were spherical and very small, this would actually be more consistent with a dark matter star than any other explanation. But the most important part of the study was trying to compare this to computer models that predict dark stars, and then seeing if the real observations seem to match. And while intriguingly, one of the first discoveries was two new objects. JWST Z14 and Z14-1 seem to have light signatures that, surprisingly, match the predictions. As a matter of fact, JWST Z14-0 seems to be the farthest bright object with a very clear light fingerprint that could be used to assess exactly what this is. And even though the object appeared as a tiny dot in some of the initial observations, its actual morphology or its shape seemed to actually match the prediction for dark stars or dark matter stars surrounded by a cloud of gas that's extremely hot. And it was also very massive, at least 1 million solar masses in mass, with some of the other objects matching these observations as well and producing very similar emissions. But here we had some other explanations without dark matter stars, so these observations were not enough. We still needed to have some kind of a signal that would be a definitive proof that this is dark stars. And well, it turns out that one of these observations did have something very unique, a very specific dip at a certain frequency, or a wavelength of 640 angstrom. This is known as the helium-2 absorption line. And intriguingly, this particular line has been predicted in various models involving dark matter stars. But this dip should not exist if this is just a galaxy or a star cluster. Although right now this observation and this dip is not super clear. We need to have additional powerful observations to establish if it's really there, and we definitely need more evidence from other objects, because right now this is relatively weak. Nevertheless, this is an exciting new evidence. However, there's also a major problem, and the problem comes from the observations based on a slightly different dip. Here, by using a different telescope, in this case ALMA, researchers also revealed a very specific oxygen line with a wavelength of 88 micrometers. And this oxygen line, if it exists, might be a problem, because here it would suggest that this object contains oxygen. And in order to contain any heavier elements, we need to have supernova, which would imply that this object contains stars that have gone supernova in the past. Or it would imply that this is not just made out of hydrogen and helium, or that this is not a dark matter star at all. Because dark matter stars should form completely by themselves and basically only contain hydrogen, helium, and just a tiny bits of lithium. And so if here we have both the helium dip and the oxygen signal, it would mean that this is maybe something even more complex. Not just some kind of a simple dark matter star, but possibly something even more complicated and something even more bizarre. Something that contains signs of dark matter annihilation, but also signs of potential supernova. Or maybe this is basically just what early galaxies were like. They were just so different and so unique that we cannot explain them yet, which actually has been the main explanation from some of the previous studies. Hello wonderful person, this is Anton, and today we're going to be discussing a new discovery coming out of James Webb Space Telescope that once again involves a galaxy we did not expect to find. And in this case you can kind of see the picture of this galaxy right here. It seems to resemble our own galaxy, the Milky Way, and is described as a grand design spiral galaxy, which for a very long time scientists believed should not exist so early in the universe. Yet in this case we seem to discover this bizarre galaxy that appears remarkably mature, despite being formed extremely close to the beginning of time itself, essentially close to the Big Bang. And so here, this discovery is now forcing us to once again reconsider some of the timelines in regards to formation of complex structures, and reconsider how galaxies like the Milky Way and of course the nearby Andromeda galaxy seem to form. Now, just to clarify, this does not violate any of the modern cosmological theories, but it does present us with a bit of a challenge. And so in this video, let's actually talk about this discovery and a few very similar discoveries from just the last few years, because this now seems to be an actual phenomenon involving what seems to be a new type of galaxies. And so today we're going to discuss main discoveries about this new class of fully formed spiral galaxies that seem to have already existed in the first 2 billion years after the Big Bang, despite the fact that the universe was still super young and still developing. And actually, let's start with this discovery first, before we discuss previous ones and compare them afterwards. So right now this is referred to as Alaknanda, named after a Himalayan river in one of the Indian states. And so here astronomers Rashid Jain and Yogesh Wadadekar spotted this using some of the data from JWST, and of course its incredible ability to detect faint light from the early universe. And well, it's really the age that makes this galaxy so exciting. It existed when the universe was only about 1.5 billion years old, or about 1/10 of the universe's current age. And so, as reported in the study, this was at a redshift of 4.6. But even at these distances and at this age, this is no longer just some kind of a blob like so many other galaxies around this time. This is now definitively proven to be a grand design spiral, or meaning that it has two very clear symmetrical spiral arms sweeping around a bright central region or a galactic bulge. But compared to some of the more well-known galaxies, including our own, here the size is much smaller. This is about 1/3 of the Milky Way at 30,000 light-years across. Nevertheless, this is still pretty surprising. And while out of all galaxies known to us in the nearby universe, 10% of all of them are usually spiral galaxies, and actually usually resemble something like this, Messier 81. And so in the modern universe, this is of course something that is expected. But even today, it's not entirely clear how they form. Now, one of the best explanations is what's known as the density wave theory, which is essentially visualized in this video. And here the idea is pretty simple. These spiral arms are not actual structures, but are technically density waves that turn around the galaxy at different speeds compared to the galactic disk. And so as many stars and a lot of gas passes through these regions because they're slightly denser, they're pulled toward the material inside these arms by the force of gravity, and as they travel through the arm, they're usually slowed just a little bit and spend just a little bit longer time inside the arms compared to the rest of the galaxy. And at the same time, this higher density of gas also causes a lot more gas to collapse into denser clumps, which then produces even more stars and results in massive amounts of star formation. And so this is technically a kind of a dynamic structure that forms in at least 10% of all galaxies. But astronomers always believed that it should take maybe a little bit longer to form. Or to be more exact, for decades the standard explanation suggested that earlier galaxies should mostly be messy and irregular, and only with time form these stable structures and form these disks. And so scientists believe that developing a grand design structure like the Milky Way should take several billion years. And because many of these galaxies are observable approximately 4 to 5 billion years after the Big Bang, here the evidence at first was pretty strong. And so this process that would require several slow steps, including the formation of the rotational disk, the formation of the central bulge and the arms, and the formation of these subtle disturbances referred to as density waves, at first was believed to be a process that requires at least 3 to 4 billion years of galactic evolution. But on top of this, the most important part was to basically avoid any major galactic collisions, because any galactic collision would most likely break this structure apart, causing it to go back to its irregular and messy shape, and basically restarting this process from scratch. And a lot of these earlier models predicted many different galactic collisions during this time, once again implying that these very complex shapes should be kind of difficult to form in less than 3 billion years. And so finding something like this at earlier times is of course a bit of a contradiction to all of these previous suggestions, with the authors in this case also noting that the galaxy seems to have structural maturity typically similar to galaxies that are billions of years older, which is of course just a little bit strange. But here this galaxy also seems to be mature for a different reason, the internal activity. And so it's not just about the shape, it's also about the formation of stars. This galaxy is forming stars at an extreme rate, approximately 60 solar masses every single year. And that's at least 20 times faster than our own galaxy, which is of course much bigger in size and mass as well. And so here this early galaxy somehow managed to pull together 10 billion solar masses of stars, organizing them into this beautiful spiral disk in a relatively short time of just a few 100 million years. And by cosmic standards, that's maybe just a little bit too fast. As a matter of fact, surprisingly, at least half of the stars here may have formed in just 200 million years. So this galaxy for some reason experienced an extremely rapid assembly and involved really complex physical processes that we currently do not understand that drove the galactic formation and formed this complex shape. And so here something is definitely operating far more efficiently than our current theoretical models. And at the moment it's unclear exactly what's happening. But one question I actually had myself at first is, how exactly were they able to produce these beautiful images, even though this galaxy is supposed to be surprisingly far away? And well, it turns out that this too was the result of gravitational lensing. In other words, this galaxy only became visible because of a dramatic gravitational lensing effect from a cluster referred to as Abell 2744, also referred to as the Pandora's cluster. And so here the immense gravity bent the light so much that it created this powerful natural zooming lens, which made the galaxy appear at least twice as bright, giving the James Webb an unusually sharp look at its internal structure. But to truly understand what's happening here, scientists had to rely on 21 different filters in order to measure everything from the galactic distance to the dust levels and the total stellar content and star formation in order to confirm that these observations were correct. And so here this is almost certainly real and is almost certainly at a distance reported. But the mystery does not end here, because this is actually not the first such object and not even the most distant. And so Alaknanda is not an isolated phenomenon. It seems to represent an unusual growing trend, marking the discovery of potentially a new class of galaxies. And galaxies discovered by the James Webb that seem to suggest that the early universe was far more evolved and more complex than we initially believed. And so let's actually take a look at this galaxy we've discussed previously, which has a Chinese name because here it was discovered by the Chinese astronomers. And so here I'm sensing some kind of a competition between India and China. But anyway, we have another disk-shaped galaxy at even farther away distance that also contains a grand design spiral shape and is also just as massive and just as large. This is known as JWST, also known as the Torch Dragon. And as you can see from this image, this is an ultra-massive spiral galaxy, currently reported as the most distant spiral galaxy ever discovered, and that seemed to exist just 1 billion years following the Big Bang. This was even earlier than Alaknanda. Here the redshift is 5.2. And despite the incredible age, JWST also exhibits a surprisingly mature structure, including a central bulge and a large star-forming disk, as well as very well-defined spiral arms. And well, here this was only discovered back in December of 2024, and so these are actually pretty recent discoveries. But previously, before that, nobody actually thought we're going to find spiral galaxies beyond the redshift of 3. Yet here this was definitely confirmed, the distance seems to be also real, and this is definitely a developed and pretty complex galaxy. And so together, along with some other discoveries from just the last year or so, Alaknanda and JWST are collectively forcing astronomers to rethink some of the previous assumptions, and specifically reassess how we believe galaxies take shape and how these massive spirals seem to form. Now, since most of the previous assumptions were actually based on computer simulations and computer models, it just means that something in these models seems to be missing, and something has to be added in order to recreate very similar galaxies much earlier on. But here, based on at least these two examples, we almost certainly have a new class of galaxies. Massive order spiral galaxies, or Milky Way analogs, that seem to form much faster than anyone anticipated and seem to contain structure associated with recent galaxies and not small irregular shapes that were previously expected. And so right now we just don't really understand how these perfect spirals form. But just as a side note, none of this breaks cosmological models, because here, for example, when looking at the types of stars, the types of gas, and the age of stars, everything still kind of makes sense. They're still as old as they should be, and the overall ideas behind the Big Bang Theory still seem to stand. So this does not invalidate Big Bang Theory, as some of the more controversial studies try to claim. Because here this basically just creates a problem in regards to how galaxies seem to develop these perfect spiral arms. And right now scientists have proposed at least a couple of dominant theories. And most of it is in regards to how early gas seems to flow inside these galaxies. First, it's possible that extremely smooth inflows of cold gas allow the natural density waves to quickly sculpt the disk into a spiral, or basically the spiral arose as a result of gas motion in some of these denser parts of the universe. And so here this would involve a lot of this cold gas, which would suddenly start to rotate in an orderly fashion, and then result in the formation of a lot of gas moving in a very similar way, which then results in a sudden and massive star formation. So just to rephrase this, basically gas suddenly started to spin in a spiral, and because it created these overdensities or these primordial spiral arms, this is when suddenly star formation started to happen. Or alternatively, the spiral pattern might have been triggered by some kind of a close gravitational interaction with a much smaller companion galaxy, such as the small satellite spheroid galaxy that has been identified very close to Alaknanda. And so here this could be just a result of gravitational disruption that suddenly forced all of this gas to move in a spiral once again. Although normally, when the spirals are formed this way, we do expect them to fade relatively quickly, which means that this is maybe not a permanent shape. But these are just propositions, and right now there is no exact solution, which means that astronomers need to try to look deeper and try to find additional examples. And even for this particular galaxy, scientists are planning to use observations from the Atacama Large Millimeter Array in order to find out if the galactic disk rotates in an orderly manner, which in this case would involve a lot of cold gas, or if it seems to show a lot of turbulence, which suggests some kind of a hot gas and some kind of a gravitational instability. So basically here, by understanding exactly how the gas is moving, may provide a few answers in regards to how this forms. But right now this definitely compels astronomers to fundamentally revisit some of these cosmic evolution timelines and to rework some of the previous models that were used for several decades. Because the evidence shows that galaxies can indeed arrange themselves very quickly and very efficiently, and the early universe was far more active and more productive than astronomers previously believed. Which obviously also has quite a lot of implications on the evolution of stars and, of course, planets, possibly even terrestrial planets similar to Earth. For all we know, maybe even terrestrial planets could have been possible much earlier, with complex planetary systems forming billions of years prior compared to previous predictions. Today, we're going to focus on one of the most bizarre mysteries coming out of the observations from the James Webb Space Telescope. Something that the James Webb unveiled in the early universe, and something that just looks like this. Tiny red dots, which is why these objects are still referred to as little red dots even today. But the thing is, these are not just pretty pictures. The discovery of these objects kind of challenges modern cosmological models, and specifically challenges our understanding of how black holes and galaxies seem to evolve. And since hundreds of such objects have been discovered in just the last few years, this has now become one of the biggest mysteries in cosmology that currently just does not have a very good explanation. Because in essence we have these very compact and very bright objects that seem to have existed anywhere from a few 100 million to possibly a billion years following the Big Bang. And at the moment nobody knows what these are and how exactly they were created. But we obviously know some things. For example, we know that these are really compact, usually no larger than 500 light years across, with quite a few of them much smaller at approximately 150 light years. This would make it much smaller than even the smallest dwarf galaxies, and obviously much smaller than the Milky Way, which is roughly 100,000 light years across. So this is less than 2% the size of our own galaxy. And the majority of these objects have been found when the universe was only about 600 million years old. So essentially when we do expect galaxies to form, except that in this case they look nothing like what we would expect a typical early galaxy to look like. But it's really the light coming from them that creates the biggest mystery. Their light seems to form a very peculiar V-shaped pattern, because in this case they seem to appear blue in the ultraviolet light, but also distinctly red in the optical light. And they also show a very broad Balmer emission line, which is usually formed by hydrogen gas, and specifically associated with very high energy activity. And so in this video we're essentially going to discuss one of the new studies focusing on one of the most famous such objects that provides us with another potential explanation that in this case might kind of make sense. But before we talk about this new study, let's discuss some of the previous propositions and explanations that also kind of make sense but don't explain everything yet. And as always, you can find all of the relevant studies in the description below. And so let's start with the main explanation and the leading idea. What if these are active galactic nuclei, or AGNs? Or basically objects powered by rapidly growing supermassive black holes in the center of some kind of a cluster, in the center of some kind of a young galaxy that's actively feeding this black hole. And so could these just be massive black holes? Well, there's definitely some evidence. For example, the previously mentioned Balmer lines. Just the fact that these Balmer lines are kind of broad suggests that the gas in this case seems to be swirling really fast around some kind of a center, and very likely moving at thousands of kilometers per second. And this is actually what we do expect from some kind of a massive black hole actively feeding on a lot of gas. And so in this case, the red color could be explained by some kind of a thick cloud of gas surrounding the black hole's feeding frenzy, and also obviously blocking some of the light, making it appear much redder. This was actually the first explanation proposed a few years back, but it seems to have certain problems. And that's because in a typical AGN, we expect a lot of X-ray emissions and also a lot of flickering, or basically changes in luminosity. Yet these objects produce no X-rays, and they also seem to have an extremely flat emission, mostly visible in the infrared spectrum, implying that they're not variable in brightness at all. Behavior that's kind of unexpected from a typical supermassive black hole. Plus, if every little red dot were an AGN, it would actually mean that there were far more supermassive black holes growing in the early universe compared to any model we have. And it would actually create a mystery of, so what happened to all of them, and why don't we see more of them around us? And so statistical analysis suggested that a simpler non-black hole based model would probably make much more sense. Okay, what if these are not black holes but instead very compact star systems, or essentially kind of like early globular clusters? Something that's present in a lot of galaxies in the modern universe, but the object whose origin is still unclear, as we don't actually know how these formed. And so perhaps the red color in this case just came from a population of very old evolved stars, which would obviously not be variable in terms of brightness and would not produce X-rays. But again, there's a bit of a problem. To explain the overall brightness of these objects and their overall compactness using just stars, we would need an impossibly high density of stars in a very small region of space, far beyond anything we observe even in the densest parts of the galaxies today. Essentially here you would need stars just a few astronomical units away from one another in a region of about 100 to 150 light years. And that also doesn't really make sense because they would very likely just collide with each other, very likely resulting in supernova and producing all sorts of additional emissions. Then, more recently, in May of 2025, an alternative hypothesis suggested that maybe these are basically TDEs. Tidal disruption events. That's of course when a star comes really close to a black hole and starts to fall apart, producing massive emissions. And so this idea suggests that little red dots might be intermediate mass black holes in the middle of super dense clusters, such as once again maybe globular clusters, actively tearing apart unlucky stars one after another. And since TDEs are known to be relatively faint in X-rays and can also produce broad hydrogen lines, some of the observations here do actually match. But the main challenge here is that it doesn't actually explain the red color. In other words, the actual emission in this case would not make much sense. Moreover, to confirm this, we would have to observe this for several years just to see slight variations. But at the moment, all of these objects seem to be more or less pretty much the same. They don't seem to produce additional emissions and variability expected from TDEs. Likewise, in July of 2025, additional propositions suggested that maybe these are just supermassive primordial stars, kind of like the elusive population 3 stars that we always thought existed in the early universe, but that have not been seen yet. And these would essentially be the first stars ever made containing only hydrogen and helium, and in theory could be quite giant, thousands or even million times the solar mass. And so here certain theories or certain propositions match the observations from little red dots, at least to some extent, specifically matching the spectra and the brightness, including the V-shaped Balmer break. As a matter of fact, this could even be possible seeds for later supermassive black holes once these stars collapse. But here this proposition is still somewhat hypothetical, mostly because population 3 stars are technically expected to be much smaller than this, and are also expected to produce mostly blue color, as these would be very massive and resemble giant Wolf-Rayet stars and not these compact red objects. And so here we have several competing ideas, with more coming out pretty much every month now, but the puzzle of these little red dots remains largely unsolved. But now we have a new study from September of 2025 that proposes something else and is maybe able to explain a lot more than any of the propositions I just mentioned. And so in this new study, Anna de Graaf and the team you see here focused on one of the most well-known little red dots discovered 3 years ago. This is known as the Cliff, a particularly extreme little red dot that's been examined several times already and whose light took approximately 11.9 billion years to reach us. But what makes this object interesting is that it has an extremely sharp, prominent Balmer break and a very sudden drop in brightness at certain ultraviolet wavelengths, with the break in this case much steeper and more extreme than what you would usually expect from typical star-forming galaxies. And a lot of previous explanations based on a lot of other studies could not actually explain why it has this and why it contains so many extreme features. It even looked more like some kind of a spectrum of a single extremely hot star than an entire galaxy. And so this led this team to propose a new phenomenon, a new model referred to as a black hole star, or BH star for short. But this is not a star in the traditional sense, as it does not get its energy from nuclear fusion. Instead, it is a supermassive black hole at the center of an accretion disk, but unlike anything we've seen before, it seems to be completely cocooned within a thick, turbulent envelope of cold hydrogen gas, with the black hole's powerful activity heating the surrounding gas so much that it then creates a kind of a fluorescent glow. A glow that's then visible from billions of light years away. And because it's cold gas that dominates the light we see, it predominantly emits in the red optical and near-infrared wavelengths, and not X-rays expected from black hole emissions. And it's this dense cocoon of gas that seems to perfectly explain the peculiar V-shaped Balmer emissions and the extreme Balmer breaks coming from this object. And so in essence, all of the emission lines could in theory be explained if this was a cocoon of gas. As a matter of fact, here, some of the emission lines also show us the absorption lines from the gas itself, and so we know that this definitely contains huge amounts of hydrogen. And crucially, this very thick, cold gas cocoon possibly also explains other puzzling characteristics. For example, the lack of X-rays. In this case, because the gas is so thick, it blocks the X-rays, preventing them from escaping. It also accounts for the flat infrared spectrum and could explain why these objects appear overmassive, as their black holes seem to be a little bit too large for their host galaxies, because much of the galaxy's actual stellar mass might be hidden or simply very small. And this explanation seems to fit other explanations from some of the previous studies and observations from other objects. For example, the object you see right here known as QSO-1, a distant little red dot at a redshift of 7 that was found to host a massive central point mass, roughly around 50 million times the solar mass, but also an object that would unlikely to contain any stellar components or any active stars. And though initially this was described to be a naked black hole, very likely in the early accretion phase, the observations of emissions do actually align more with this black hole star hypothesis quite well. And so here we have this new concept of a dominant black hole within some kind of a gas envelope, with certain other little red dots even showing the high excitation iron emission lines, which would suggest extremely dense gas and very high temperatures near some kind of a central source, exactly what you would expect from a powerful AGN heating a very dense gas envelope. But what's even more exciting about this black hole star hypothesis is the implication for the idea of black hole growth. Because here, for years, scientists struggled to explain how black holes could grow so fast, so quickly, in order to acquire billions of solar masses in certain galaxies near us. And so here, these black hole stars could represent crucial early phases in the black hole evolution, where the black hole forms rapidly by consuming huge amounts of cold gas very quickly, and actually growing faster than theoretical maximum limit or previous assumptions based on previous models. And so the current thinking and the current explanation for these little red dots seems to suggest that these are black holes after all, and very likely first black hole activity in some kind of a young galaxy, with the black hole that forms eventually becoming covered in the cocoon of gas and then rapidly growing for what seems to be hundreds of millions of years. But eventually this fog will disappear and the object evolves into something more typical, such as a quasar or a blazar that we usually detect at least 1 billion years after this. And so this black hole star explanation right now seems to explain most of the emissions and most of the observations. But since this is a continuous journey, this is still a very early proposition, and so only further observations and further analysis can tell us for sure what's going on here. Although intriguingly, even after 3 years, this is still just as mysterious as it ever was. In today's video, we're going to be diving into some really incredible discoveries from the James Webb Space Telescope. Discoveries that, once again, don't really make sense, and discoveries that are currently super difficult to explain. And I guess let me show you what we're actually discussing. It's something right here. And yeah, it's very difficult to see. Yet based on one of the recent studies, researchers are now pretty certain there seems to be something unusual in here, and it's something scientists now refer to as Capotaro, or maybe Capotauro. I'm actually not entirely certain how to pronounce this. Either way, you can kind of see it right here. And so once again, James Webb was able to push the boundaries of current observations and presents us with something that we currently cannot explain. And so either this is something that's going to force astrophysicists to completely rethink how the first stars and galaxies came to be, or maybe this is some other bizarre object much closer to us, and potentially something that once again we've never seen before, but is nevertheless just as exciting. And so let's talk about Capo Tauro a little bit more, and discuss some of the most likely explanations we have right now. Now first, what exactly is this, why is it so strange, and how exactly was it discovered? Well, right now the most likely explanation for this is that this might be the farthest galaxy we've ever seen. But the scientists behind the study proposed this with a lot of caution. But first, let's discuss some of the important concepts when it comes to observing these objects, just so that we're all on the same page. Let's start with the idea known as the cosmic dawn. The idea that was mostly based on theoretical predictions and certain glimpses from the older telescopes like Hubble that suggested a gradual slow build-up of stars, and of course galaxies, that very likely lasted for a few 100 million years, but was also initially thought to have begun a few 100 million years following the Big Bang. You can sort of see this summarized in this image from NASA. And so the first galaxies were believed to have started approximately 400 million years following the Big Bang, with the first stars appearing after 200 million years. But then as the James Webb started to observe the same region, it started to discover something maybe a little bit different. It almost immediately became pretty clear that the universe was much more active and way more chaotic, and seems to have formed galaxies much quicker than expected. And so even though observations from Hubble sort of met the expectations, here the Hubble telescope could only see up to the redshift of 11, or basically approximately 500 million years following the Big Bang. But the James Webb, that was specifically designed to observe the infrared light, was able to see much farther away and was able to detect objects from distances nobody expected. And as of May of 2025, so essentially just a few months ago from when I'm making this video, the most distant confirmed galaxy is what's known as MOM Z14. The galaxy you can learn about in one of the videos in the description, and the galaxy that already existed 280 million years following the Big Bang. With this being a very bright, very compact object, but also forming stars at a ridiculously fast rate in a virtually dust-free environment, with a total mass equivalent to the Small Magellanic Cloud, one of the satellite galaxies of the Milky Way. So this was a large galaxy, a bright galaxy, and of course was a huge discovery that surprised pretty much everyone. And so even this galaxy presented us with a bit of a challenge. The models struggled to explain how this object with so much mass and so much luminosity could form so quickly. And that's because the gas in the early universe was supposed to be way too hot, which would make it much more difficult for stars to collapse and to form rapidly. But the James Webb might have outdone itself once again, because this time by using a technique known as near-infrared dropouts in order to spot ultra-distant objects, researchers behind this recent study spotted something that seems to be even more bizarre. But here it's actually important to understand what this means. So when the telescope observes something, it actually looks at different wavelengths by using very specific filters. You can see some of them in this image. Here's what this instrument and the filters look like, and you can see each of them represents a very specific wavelength. And so these filters detect galaxies by capturing their light across a very specific range of wavelengths. But in these observations, using multiple filters is very important, because it then enables us to see through cosmic dust that usually obscures galaxies in visible light. And specifically, it also allows us to detect key spectral features, such as, for example, very specific hydrogen emissions, whose redshift can then be used to approximate distances. And so here, by looking at how bright the galaxy appears in various filters, it becomes possible to estimate the approximate distance, because the galaxy becomes only visible in certain wavelengths, but not in others. And so if by some chance we find a galaxy that seems to be invisible in most filters, but is still visible in some of the longer wavelengths, it potentially suggests we've discovered one of the most distant galaxies discovered so far. Here's, for example, observations of a typical galaxy at average distances, and so it's only really absent in one of the filters, but is still visible in 5 others. And that's not at all what we see here. This object is invisible in most filters, and is barely visible in just 2, which is technically what this technique was called, near-infrared dropouts, or any object only visible in these extreme wavelengths, and not visible in anything else. And so the point was to look for objects that suddenly disappear, indicating a significant break in their light spectrum. And that's how they found this Capo Tauro, named after an Italian mountain. And this seems to be an extremely faint object, only visible in the Sears survey, but also characterized by an extreme dropout at 3.5 micrometers. And here, when scientists including Giovanni Gandolfi and his team analyzed the light coming from this object, they got an incredible result. The preliminary redshift for this seems to be 32. And yeah, let me repeat this again. 32, which is way higher than 14.4 from that previous record holder. And so what does redshift 32 mean? Well, it means we're seeing Capo-Tauro as it was when the universe was only 90 million years old. If we go back to that image of NASA's history of the universe, you would essentially be somewhere in the middle right here, where we technically did not expect stars to even exist yet. And this would also be about 200 million years before that previous record holder, MOM Z14, and would also represent the very beginning of cosmic time, comparable with the formation of the first stars and first black holes in the entire universe. Making this not just the record galaxy, but also a kind of a window into the unimaginably early era, with very deep implications for how we understand galactic formation and galactic evolution. But there's obviously a lot of unanswered questions and a lot of puzzles in regards to this object. For example, Capo-Tauro appears unusually bright for such an early object and for something so far away. Here, its rest frame UV luminosity is comparable to some of the most distant sources known today, including massive galaxies like GNZ11, suggesting that its mass is at least 1 billion solar masses, and suggesting that if this is real, our models just cannot explain this at all, because it's only 90 million years after the Big Bang. It would essentially require ridiculously fast star formation with 100% efficiency, which goes against all models. But before we get too excited and before someone starts cancelling the Big Bang theory once again, this is a very early candidate. Because as we've learned from some of the previous candidates and previous detections with the JWST, the universe has a tendency to produce these mimics, objects that at first appear really far, but when scientists conduct more thorough observations using spectroscopic analysis and specifically looking for elemental emissions that then allow us to determine exact redshifts, in most cases all of these objects turn out to be much closer, sometimes actually in the local neighborhood. And on top of this, there might be some contaminants or interlopers that can cause sharp drop in light, potentially making this look like a distant galaxy. For example, this could be a dust-obscured galaxy where the light is just missing, but in reality this is just at a much lower redshift. So if this is just an object covered by dust, it might produce similar emissions. But even though dust could maybe explain some of this, Capo-Tauro's extreme break strength makes it quite difficult for dust alone to reproduce all of these infrared emissions. At the same time, there might be something more exotic here, such as a mechanism like a compact active galactic nucleus or a compact black hole, covered by a dense gas-rich environment that scientists now refer to as little red dots. And so objects like the cliff or MOM BH1 could also serve as one of the potential explanations, especially because when it comes to these objects, we barely understand them as well. But at the moment, the emissions from the little red dots still seem to be just a little bit different from Capo-Tauro, or Capo-Tauro. I seem to pronounce this word different every time. Likewise, there's also something known as strong line emitters, foreground galaxies with very intense but very specific colors that can sometimes trick us into thinking they're much farther away. Here's one such object we discussed previously, Ceres 93316. This was initially thought to be a candidate at redshift of 16, but turned out to be much closer with a redshift of 4.9. And so this is maybe one of the potential explanations. But there is also a much more exciting and even more bizarre explanation that also makes sense. Maybe this is not a galaxy at all, and maybe this is not even something that's far away. This could also be some kind of a cold substellar object, such as for example a brown dwarf or even a free-floating planet, with very distinct atmospheric absorption features that can also produce these very sharp drops in light, possibly resembling a distant galaxy. In other words, there's a chance that this is not something super far away, but is instead an object right here in the Milky Way that seems to be just some kind of a planet. As a matter of fact, the light signature in this case seems to resemble very cold brown dwarfs such as Y2 or Y3 types, whose temperature is usually around 300 Kelvin, or actually not so different from what we have right here on planet Earth. In other words, there's a slight chance that what we're looking at here is something with a temperature of Earth, but something that's drifting through space completely by itself, without a star. But in order for this object to resemble Koputauro, it would still have to be relatively far away, possibly hundreds or even thousands of light years away from us, which is technically not impossible. And if confirmed, this would make it super exciting. This would be a record-breaking cold distant brown dwarf, which we've only seen close to us at a distance of about 50 to 60 light years. But this would also suggest that this object is pretty old, because if it's real, it would be located inside the thick disk or even the halo of the Milky Way, so essentially outside of the thin disk that contains most of the stars. In this case, by being inside the halo or inside the thick disk, this object would probably be billions of years older than the solar system and planet Earth. And so whether this is a brown dwarf or some kind of an exoplanet with 13 masses of Jupiter, this will be the first such object discovered with terrestrial-like temperatures and observed at such ridiculous distances. But the main problem with that explanation is probability. The chance of detecting such a substellar object in this survey based on this one observation is extremely low, just 3%. And so I guess to summarize, we have no idea what this is. But whatever this is, it seems to be super exciting and seems to be the first such object discovered in any of the JWST's observations. But honestly, in terms of astrophysical explanations, right now the planetary object makes just a little bit more sense despite low probability. Mostly because if this is an astrophysical object super far away, it's going to be ridiculously difficult to explain this. And so even if it's not a redshift 32 galaxy, this is going to be an exciting object to come back to and discuss more once there are some additional observations. But whatever this is going to force us to rethink everything we thought we knew about the universe and about either galaxies or planets. Because if this is something far away, it means that structures like stars, black holes, or galaxies might have been incredibly good at forming early on. Hello wonderful person, this is Anton, and today we're going to discuss some of the new updates and some of the new observations and new discoveries from the most distant galaxy we've ever seen. The galaxy that you see right here that was discovered less than 1 year ago, basically beating all previous records. And no chances are in the next few years, researchers might discover an even farther candidate, because right now this is the farthest object we've ever seen. It's obviously created a lot of excitement with many new studies and new observations trying to actually figure out what's going on here. And so let's discuss this galaxy in a bit more detail, starting with a very brief review of how this galaxy was found. Naturally, this was discovered by the James Webb Space Telescope, and specifically inside the survey known as JWST, JWST Advanced Deep Extragalactic Survey. The survey that's somewhat equivalent to the famous Hubble Deep Field, when the Hubble Space Telescope observed a single spot in the night skies over 10 consecutive days. And just like with the Hubble observations, the point here with the James Webb Space Telescope was basically very similar. Pick a point that's pretty dark and that doesn't seem to contain anything and stare at it for a very long time, essentially using long exposure. And the main purpose here was to try to find super distant, practically invisible objects that no other telescope has ever seen. And naturally, after approximately 130 hours of observations, lots and lots of new galaxies suddenly appeared in the middle of nowhere, visible in the image right here, or in the image you can explore by yourself in one of the links in the description. And though this actually looks like a relatively large image, in reality, this is actually comparable to a tiny grain of sand placed on your fingertips and then extended to an arm's length, roughly around 2 feet away from your eyes. That's essentially the size of this image if you were to look at this in the night skies. And so inside this super tiny grain, James Webb was able to detect thousands and thousands of different, never before seen galaxies. And almost right away, a few of these galaxies kind of stood out, mostly because they appeared to be extremely far away due to their apparent redshift. And obviously it took a few months to confirm them. This one eventually won. JWST Z14-0 currently seems to be the farthest galaxy we've ever seen, but the initial observations from the James Webb and the spectroscopic analysis suggested the redshift of 14.32. And in terms of actual physical distances, you can actually use this pretty cool calculator by Ned Wright from UCLA to convert any redshift into light years. And so here, 14.32 suggests that the light traveled for 13.43 billion light years, but also that it traveled for 33.9 billion light years in terms of distance. This is because of the expansion of the universe, which made the light travel a much farther distance. And so because of this discovery, in the last few months there's been a lot of different studies trying to conduct additional observations just to find out what's going on here. And so in one of the recent studies, researchers actually used a different telescope in order to confirm this galaxy and its distance using different observations. They actually used the ALMA telescope, which can see things in the microwave and can detect things a lot more accurately. And here, even though they managed to confirm the existence of the galaxy, the distance was recalculated to be a little bit closer. And this was based on super accurate microwave observations, specifically focusing on emissions of oxygen, with the observations suggesting the redshift to be 14.1793. And so here, if we actually change this, the overall distance changes by just a little bit, suggesting that this galaxy is maybe 4 million years younger than we actually thought. Definitely a minor difference. But once again confirming that this is still the farthest galaxy ever seen, and more importantly confirming that this galaxy seems to be indeed somewhat unusual. Unusual in a sense that it seems to be way more advanced than expected, but not like super advanced. So basically here it doesn't actually break major theories like the Big Bang theory, but it does suggest that the star formation very likely started much earlier than we thought, with the first galaxies assembling earlier as well. And also suggesting that the overall star formation and the overall galactic evolution seems to be entirely different from how we imagine it to be, or from how it was previously simulated by various computer simulations such as the Illustris project you see right here. In essence, there was a major discrepancy between supercomputer simulations and the actual visual evidence. But let's actually briefly discuss exactly what these differences are. First of all, the size. Previous simulations established that around this time, or about 290 million years after the Big Bang, galaxies should be maybe a few hundred light years across. This one though was approximately 1600 light years. So basically still something like 70 times smaller than the Milky Way, but much larger than anticipated. Also surprisingly, this was extremely bright, which is of course the main reason we're able to see it. It's quite likely a lot of other galaxies are probably present here as well, we just don't really see them, but this one is super visible because it seems to be extra luminous. As a matter of fact, it seems to contain approximately 500 million solar masses in mass in terms of active stars, and that's once again several times more than expected around this period. And most of the models and most of the simulations do not predict anything like this at all, mostly because there's just not enough time for galaxies to grow so massive and so bright, and the brightness in this case basically indicates extremely active star formation, which is also unexpected during this period. This is essentially during the period referred to as the Dark Ages, which researchers always believed was basically when the stars were still kind of picking up in strength and the galaxies were only starting to form. Yet here we see something that's super active and is already growing very fast. But the much more surprising detection came from several recent studies, and mostly because of a very specific wavelength. Here this was from the MIRI instrument on top of the James Webb, and specifically the 7.7 micron observations. In more layman terms, an extremely specific wavelength able to detect very unique emission lines. And so here several independent studies confirmed the same thing. They confirmed the presence of extremely strong ionized gas emissions, and specifically the oxygen emission line known as O3, a super strong emission of oxygen that's actually never been seen before from such a distant galaxy. And because in astronomy oxygen is technically a metal, this also makes this galaxy very high in metallicity. The concept you can learn about in some of the previous videos in the description, and that is super unexpected. We actually expect this galaxy to be predominantly hydrogen and helium, yet this strong emission line of oxygen suggests otherwise. Essentially here what we're seeing is a somewhat metal-enriched galaxy that seems to have already existed 294 million years after the Big Bang, once again confirming that the galactic formation theories are currently incomplete, but also definitively confirming that the early universe was just extremely different from how we imagine it to be. Here this kind of reinforces the idea that a lot of galaxies in the early universe potentially evolved much more rapidly and with intensity that we never imagined. This has actually also been confirmed by observing a lot of different quasars and a lot of unusual objects we discussed previously referred to as little red dots. You can learn about this in the video in the description. And so here right now the best explanation we have that once again seems to be aligned with the observational evidence is that this galaxy potentially had an extremely powerful starburst activity or some kind of a massive star formation burst in the last few millions of years that suddenly enriched this galaxy with highly ionized oxygen molecules that are now emitting so much bright light specifically ultraviolet light, that it's visible from billions and billions of light years away. And because it's so far away from us, this light has been redshifted to be visible in 7.7 microns, or basically mid-infrared. But because we now see signs of metallicity in a super distant galaxy, it definitively confirms that even inside this galaxy, it already experienced several very powerful supernovae that managed to convert all of this primordial hydrogen into much heavier elements such as oxygen. And because this is a continuous event with a lot of powerful stars nearby, this oxygen becomes ionized and becomes super bright. And so right now researchers believe that this galaxy very likely has been doing this for at least 100 million years, implying that this galaxy is approximately 100 million years old, but also putting the birth of this galaxy right at the edge of the Dark Ages. So this galaxy seems to have been born as soon as some of the first stars formed as well. And right now these observations are extremely accurate. Here we have 43 hours of observations with the MIRI instrument and 167 hours with the NIRCam. This actually took approximately 9 days of observations in total. And so the existence and the overall properties of this galaxy have been measured extremely precisely. But there are obviously still some things that don't really make sense. And so some of the studies try to solve this by basically trying to imagine, or essentially trying to explain, what this region was like just a few 100 million years following the Big Bang. But here some of the conclusions can also be made by not what we can see, but also what we can't see. And specifically here researchers do not actually see any carbon, and specifically the C2 emission line, which very often represents cold gas or molecular gas, usually detected in many different galaxies, which basically suggests that this is a galaxy with extremely ionizing conditions, or extremely bright, very powerful and very massive stars, emitting a lot of ultraviolet light and a lot of ionizing radiation, which to the scientists behind one of the studies in the description suggests that this galaxy is extremely likely surrounded by a lot of neutral gas, or essentially this pristine primordial hydrogen gas that was present everywhere in the early universe and is usually the reason why a lot of galaxies far away become invisible in certain wavelengths. And so in a nutshell we have a galaxy that seems to be evolving really quickly and seems to also contain extreme interstellar medium conditions with a lot of ionized gas and ionizing radiation inside of it, but as expected is also surrounded by a lot of neutral hydrogen and a lot of cold gas, which in some sense once again confirms many other theories and many other predictions. And so in that sense the Big Bang theory and all of the ideas we have about the evolution of the universe are still more or less correct. It confirms the Dark Ages, the presence of neutral hydrogen, and the ionization of this gas by some of these early galaxies. But one of the more important discoveries in this case is actually the fact that we even found this galaxy, since this galaxy was discovered in a tiny piece of the night skies, comparable to a sand grain approximately 2 feet away from your face. Here this also suggests that many such galaxies are very likely going to be discovered in additional observations in other regions of the night sky. And those additional observations will very likely explain a lot more. But at the moment what we can say for certain is that this is indeed an extremely active and rapidly evolving galaxy that seems to have formed quite rapidly within approximately 100 million years and already contains more stars and even more metallic materials compared to what we thought is possible. Exactly why though is not a question we can answer yet. Hello wonderful person, this is Anton, and today we're going to discuss yet another bizarre discovery coming from the James Webb Space Telescope that once again might not make a lot of sense at first. And in this case it's again an unusual galaxy containing something super strange inside, possibly representing some of the biggest stars we've seen anywhere. But as you might have learned from some of the previous videos, this is not the first time James Webb discovered something that's super bizarre and difficult to explain. And so let's talk about this new discovery coming from a galaxy referred to as GS3073, the galaxy that you see right here, and talk about why this is unusual and what seems to be happening here. And I guess in this case, let's start with the galaxy itself. First of all, like previous discoveries, this is an AGN, active galactic nucleus. In other words, it's a galaxy that contains a relatively active black hole in the center that's then responsible for producing a lot of very powerful emissions visible from billions of light years away, which is of course the main reason we even found it. And it is pretty far away, redshift of 5.55, or essentially when the universe was only about 1 billion years old. So this is not the most distant galaxy, but it is pretty far away. And in this case we have two separate teams with two separate studies around the same time that both essentially confirm the same thing. First, there is a very active, very massive black hole in the center, and second, the chemical analysis of this galaxy does not actually make a lot of sense. And so in this galaxy there seem to be quite a lot of somewhat unusual observations. For example, the black hole itself has already been confirmed to be overmassive, as in it seems to be much larger and much more massive than expected for a galaxy of this size at this time. But the true mystery of JWST is really in the elemental composition and the ingredients inside the galaxy, because here the chemical signature is just bizarre and seems to be entirely different from a lot of galaxies we've seen around the same time. And right now, I guess just to give you a little bit of a spoiler, it seems to point at the existence of enormous stellar giants that up until recently have been purely hypothetical. But here we're talking about stars in tens of thousands or even hundreds of thousands of solar masses, basically representing the largest stars in the entire universe. And so let's talk about the evidence first and why researchers seem to think this might be the case. And so to understand why JWST is so unusual, we must first quickly look at how stars usually produce elements that eventually make up galaxies. So first, when astronomers talk about galaxies, they usually use the concept of metallicity. This refers to the abundance of elements heavier than hydrogen and helium, with a lot of these heavier elements like oxygen, carbon, and nitrogen basically being the product of stellar explosions or supernova. So if we have a lot of these carbons, oxygens, and nitrogens, it means that the galaxy has been enriched and the galaxy is no longer primordial and has very likely experienced several generations of stars. And while in the local modern universe, scientists established very specific relations that govern how these elements appear, with things like oxygen and nitrogen usually following slightly different timetables. For example, when it comes to oxygen, it's usually synthesized quite rapidly inside some of the largest stars. So here we're talking about stars heavier than 8 solar masses, with a lot of these stars eventually creating a Type II supernova or the core collapse supernova that blasts all of this oxygen into the surrounding space. This is something that we even observe today all over the place. But nitrogen is a little bit different. It does take longer to produce and mostly comes from the internal fusion process within intermediate mass stars, usually between 2 and 8 solar masses. So it basically requires very specific conditions. And in this case, these types of stars release nitrogen much later in their lives, usually during a phase referred to as asymptotic giant branch star. And this always represents a late phase of evolution in certain stars, when they appear as very bright red giants with a very luminous and very large outer envelope. And though in this case the core usually consists of carbon and oxygen, this is when they also produce nitrogen. But nitrogen enrichment usually lags behind oxygen enrichment just because of the types of stars it's produced in. These stars are much smaller and usually live much longer, and so we actually expect a lot of nitrogen in galaxies that are more evolved. And so young, developing galaxies, especially those with relatively low metallicity, are also supposed to show low nitrogen to oxygen ratio. So we might see some oxygen, but we're probably going to see almost no nitrogen, which based on what we know about star formation and star evolution, sort of kind of makes sense. Or really I should say made sense until now, because the data from the near-infrared observations of this galaxy, with the additional observations by the Very Large Telescope, seem to show us the opposite. Here, scientists found that this galaxy exhibits an exceptionally enriched nitrogen abundance compared to oxygen. Specifically here, the so-called NO ratio, which was discovered by observing ultraviolet emissions coming from specific regions, seems to be approximately 20 times higher than the solar ratio, or basically what we see inside the Sun. And this incredible level of nitrogen enrichment puts this galaxy amongst the most extreme nitrogen-rich objects discovered at these distances to date, or technically even some of the most nitrogen-enriched objects for at least the first few billions of years in the existence of the universe. And so this actually creates a bit of a paradox. Given the overall low elemental content or metallicity, this galaxy seems to be a little bit too young and seems to be a little bit too underdeveloped. So it really should not have any nitrogen at all, at least using the normal process involving these intermediate mass AGB stars. So essentially stars that we usually see producing nitrogen. And so something here definitely doesn't add up. But things get even more complicated when we look at where this is located. or basically when we look at how the chemicals are distributed with a process known as chemical stratification. And that's because this galaxy is not uniformly rich in nitrogen and seems to have very specific concentrations. And so here, by analyzing different wavelengths, scientists discovered that there seem to be two distinct regions. First one is the wider outer region. When observed using optical emission lines that usually trace gas that's a little bit less dense, scientists discovered that the galaxy shows subsolar nitrogen amounts, or basically it seems to be relatively normal. And so here the outer region currently makes a lot of sense. But the dense inner region is super strange. Here the central gas that was traced through the UV emissions, which also shows us much denser particles, seems to show us a lot of highly ionized gas, and that's where it seems to be also dramatically enriched in nitrogen. And so most of the extreme nitrogen overabundance is basically in the center, or very close to the center, because we don't actually think this is coming from the black hole. And this tells us that the enrichment was highly localized and very likely involved a central event, possibly inside some kind of a very dense region, with this enrichment not spreading to the bulk of the galaxy, but only happening in a very small area, possibly area that's just a few hundred light years across. And surprisingly, in this area, compared to nitrogen, carbon is not enriched either. So basically both carbon and oxygen seem to be very similar to what we expect from a typical star-forming region, but nitrogen is dramatically enriched. And that means that atypical slow-acting stars or medium-sized AGB stars cannot explain any of this. They cannot explain why this region is so enriched in nitrogen, yet does not have as much carbon or oxygen. So what exactly happened then? Well, right now there is maybe one exotic solution. Here, the evidence from both of these studies and the overall conclusion is that this might involve the hypothetical concept referred to as SMS, supermassive stars. And these are hypothetical stars that are ridiculously massive and possibly similar to population 3 stars. We're not actually entirely sure if they're the same or not, and were very likely formed from pristine hydrogen and helium, representing the leftovers from the Big Bang. But because they lacked heavier elements, which usually limit how massive a star can get, these early conditions allow these stars to form into really massive objects far beyond the typical mass of about 150 solar masses. And so here the model suggests that supermassive stars potentially explain what we're observing. If they have a mass of anywhere from 1,000 to maybe 10,000 or even more solar masses, they would actually create these giant factories producing nitrogen, which would explain why we're seeing this. And so during the primary fusion phase, or the core helium burning, their massive turbulent interiors convert most of the carbon into nitrogen, which then is dispersed throughout the stellar envelope and escape through these very powerful stellar emissions. And critically, based on the models used in these two studies, the extreme nitrogen to oxygen ratio seems to simultaneously match the observations of relatively normal carbon, oxygen, and even neon ratios discovered inside this galaxy. In other words, based on the models, the actual chemical observations seem to match the predicted models. And if confirmed, it would make JWST 3073 a crucial galaxy. It's basically a kind of a fossil with a chemical imprint left behind by some of the most massive stars we've ever seen. Now once again, we're not sure if this is population 3 stars, but they probably are, the first stars in the universe. And so if the discovery is one day confirmed, this has a lot of implications for cosmology, even when it comes to things like, for example, supermassive black holes. Specifically, the existence of supermassive black holes so early in the universe. If the black holes started from the collapse of stars, and they actually started from these supermassive stars, it would explain why we're seeing so many very massive black holes, as we've discussed in one of the previous videos, in extremely early universe. Because in this case, these supermassive stars, like those discovered in JWST 3073, provide an efficient alternative. A lot of these black holes can basically form from really massive stars collapsing into black holes, making something that's already tens or even hundreds of thousands of solar masses in mass after just a few million years. And even in this galaxy, where the black hole is possibly over 100 million solar masses in mass already, a very similar process could have taken place a few million years prior. Here, a supermassive star could have created a really massive central black hole, thus explaining the chemical anomaly, and of course explaining why this galaxy contains such a massive black hole in the center. The black hole that's once again overmassive compared to everything else. But once again, because this is a brand new discovery, this is still just a hypothesis. For example, some of the previous propositions about these supermassive stars and population 3 stars suggested that they should form in pristine environments, basically environments containing pure hydrogen and pure helium, and not a galaxy like this one that's already kind of more or less mature. And so here it doesn't seem to match the environment perfectly, and we don't really expect primordial massive stars to exist in a similar galaxy. But then again, maybe these propositions about supermassive stars and primordial stars are just initially incorrect. As in, maybe they can form anywhere, and maybe that's exactly what's happening here. And so the fact that this galaxy is so enriched in nitrogen, and this has not been confirmed by two separate teams, is already enough evidence to suggest that something super bizarre is happening here, and most likely involving these extremely massive stars. Unless, of course, in some of the future studies, someone discovers a completely different method that seems to produce so much nitrogen all at once, which basically would suggest that the chemistry in the early universe was just kind of different. Maybe stars could produce these elements in some other way that they're just not able to do anymore. But there's really no evidence for any of this, so right now supermassive stars still represent the best explanation. And really the best piece of evidence we have here is the fact that this is all so localized and in such a small region. An extremely dense region close to the central black hole that possibly just contains some kind of a very small stellar nursery. And so here it just seems to involve very strange stars. And that means that we'll probably be discussing this object in some of the future videos once there's some additional updates, because at the moment that's really all we know. And so right now JS3073 provides a very important test bench for many different models of chemical evolution in the young universe, but also provides some of the best evidence we have for the existence of supermassive stars that might have served as early seeds for supermassive black holes. Hello wonderful person, this is Anton, and today we're going to be delving into some of the most incredible discoveries coming out of James Webb Space Telescope in the last few months. Because once again, this telescope has been able to push the boundaries of our understanding when it comes to early universe. And here, these observations are so unexpected that they're forcing astrophysicists to reconsider certain models when it comes to the formation of early galaxies and early black holes. And so let's discuss some of these recent discoveries in a little bit more detail and discuss why this is important and what's most likely going to happen next. And as always, you can find all of the studies relevant to this in the description below. But first, let's talk about why this is important and what exactly these new observations are trying to reshape. Now, for years, our understanding of early universe, specifically of the period known as the cosmic dawn, has mostly been shaped by theoretical predictions and only some observations from telescopes like the Hubble. And pretty much all of these early observations and predictions painted a picture of a gradual emergence of stars and galaxies that seems to have happened in the first 400 million years. But the observations from JWST pretty much started to change most of this as soon as it began its operations. And it pretty quickly became very clear that the universe was way more active and way more chaotic in these first millions of years following the Big Bang. Now here we obviously have to understand the concept of redshift. This is essentially the cosmological concept used when studying the ancient universe. As the universe expands, and as the light from distant objects gets stretched to longer and longer wavelengths, the objects get higher redshift, with some of the most distant objects discovered by the Hubble Space Telescope essentially having the redshift of 11, although technically the highest spectroscopically confirmed galaxy was only at the redshift of 9. This would be approximately 600 million years following the Big Bang. But because the James Webb Space Telescope was specifically designed to observe infrared light that would represent ultraviolet light redshifted to be infrared, here it was very good at detecting luminous galaxies much farther away, with at least several galaxies now confirmed to be at a redshift of 14, or approximately 300 million years earlier. The most distant detection is approximately 280 million years following the Big Bang. But even these detections presented us with significant challenges. Here the suggestion was that there were just too many massive galaxies forming too early, and there seemed to be a little bit too many luminous sources that were just a little bit difficult to explain. And that's because, as I previously mentioned, a lot of this was based on theoretical predictions, with many of these predictions suggesting that it should be relatively difficult for stars and galaxies to form so quickly. And that's because the gas in the early universe is supposed to be super hot, and that would make it much more difficult for stars to collapse into dense enough objects to become stars in such a short time frame. Yet as far back as a year ago in 2024, we definitely had several confirmations of extremely distant galaxies at a redshift of at least 14. This was confirmed by several independent observers, so it was very difficult to argue with this. But now we have something even more incredible just a year after. This new study by Perez Gonzalez and his colleagues utilized some of the deepest JWST observations, mostly from the MIDIS and NG-Deep surveys. These are surveys designed specifically for deep extragalactic exploration. Not like Star Trek style exploration, we're just talking about looking at things. And these new observations were able to achieve extremely accurate results, identifying 9 new candidates. Candidates with 5 sigma detection, suggesting that they're almost certainly there, but candidates that seem to have a dramatic drop-off in certain infrared frequencies. You can actually see this visualized right here, because one of these objects is only visible in certain wavelengths, but not in other wavelengths. And that implies an extremely high redshift. For 6 of these objects, they seem to have an F200W drop-off, which indicates the redshift of approximately 17. That's about 200 million years following the Big Bang, and at least 80 million years younger than previous detections. But the biggest shocker was the 3 other detections that seem to have an even higher dropout, consistent with a redshift of possibly around 25. That's just 100 million years following the Big Bang, making this the youngest and the most distant object ever observed. And that by itself is super extraordinary. Nothing that far has ever been seen before. Although here we have to, I guess, mention a really important side note. Right now these observations are only based on redshift, estimated based on what we see in different filters. This is not an exact distance, and the exact distance can only be determined through additional observations by actually seeing specific elements inside these objects, such as for example hydrogen and helium, and by then seeing the redshift in the absorption lines of those elements only. And so at the moment this is still a preliminary distance, but nevertheless this is still very exciting. Exciting because we also get to estimate some of the properties of these ultra-high redshift candidates. For example, here we can estimate their mass. They seem to have around 10 to the power of 7 solar masses, with the estimate based on the mass weight, suggesting that they're approximately 30 million years old. So these are very massive but also very young objects. They also seem to contain a relatively low amount of dust. And based on the observations of ultraviolet emissions from these objects, researchers think that this points at young metal-poor population 3 stars, or possibly some other powerful objects with a lot of ionizing radiation. But more importantly, when it comes to the actual shape, here there seems to be a kind of a mix, with some candidates appearing compact and point-like, and a radius of approximately 180 light-years, while others are at least 2 to 5 times larger, up to about 700 light-years across, and seem to be more extended. And this morphological diversity is quite important when considering different explanations for their apparent luminosity. We'll discuss this in a second. But importantly, there also seems to be a kind of a relationship when it comes to distance versus luminosity density. Here, the observed number of density inside galaxies seems to dramatically increase with distance. And so at a redshift of 17, the overall density inside galaxies is 4 times smaller than at a redshift of 12. Whereas the most distant objects at the redshift of 25 seem to have 25 times less density compared to much closer galaxies at redshift of 12, suggesting that these are extremely young, primitive objects, much smaller in size and much less massive compared to what was observed in 2024 and in 2023. But this rapid buildup of stars does present us with a bit of a challenge, mostly a challenge when it comes to galactic formation. And specifically because of the hypothetical dark matter that's supposed to guide the formation of galaxies early on. It basically means that a lot of these halos would have to be way more efficient at converting baryons into stars, and more effective at forming dense complex structures very early on. Or alternatively, maybe these early stars were actually just much more effective at producing energy and light. Maybe they had much higher emissivity, producing way more UV photons per stellar mass. That would explain why they're so easily visible, but it would not explain why they're producing more energy. Although because we've never seen these primordial stars or population 3 stars, we obviously know nothing about them. However, a separate study does provide us with maybe one alternative explanation. what if these are not really galaxies and not really stars? But instead, as the study by Materi and colleagues explain, because of this outrageously high number densities, and obviously extremely far away distances, what if what we're seeing are primordial black holes? As a matter of fact, in this study, researchers go through a lot of detail trying to essentially explain how this cannot be galaxies or stars, and how it seems to be virtually impossible to reconcile with current galaxy formation model predictions simply based on this being stars. And so the proposal here is that the implied ultraviolet luminosity could be explained by primordial black holes, hypothesized to have formed in the first few seconds following the Big Bang itself. And the idea is that these primordial black holes, or PBH, with masses in tens of thousands of solar masses, would probably reside in low-mass dark matter halos and accrete surrounding gas extremely fast. They would essentially represent a kind of a collapse point for a lot of gas densities that were circulating in the early universe. And as these black holes started to collapse, and as the accretion disk around them started to emit light, it would start producing the effects we're observing. And so in this scenario, for redshifts greater than 15, all of this ultraviolet luminosity would be mostly dominated by emissions from these super early, super young primordial black holes, which is what we're seeing, and not light coming from stars. Essentially, they're suggesting, just like the models predicted, stars did not exist yet. And intriguingly, in this model, or in this hypothesis, there seems to be some support based on the observations. For instance, point-like morphology for some of these objects. They're just a little bit too small to be early galaxies or even early clusters, but would be much easier to explain if these were black holes. The overall emissions coming from these sources seem to be just a little bit too similar to what we usually see from central black holes in a lot of different galaxies. But more importantly, the overall mass and the overall number of these objects seems to be directly consistent with predictive models that previously suggested the existence of these primordial black holes. And if this hypothesis is correct, it would obviously have profound implications on cosmology. First of all, it would strongly disfavor stellar origins for the seeds of black holes, suggesting that black holes do not need stars to form. They just need a lot of mass, in just the right amount, to directly collapse and become black holes right away. On top of this, it would also suggest that many of these primordial black holes potentially served as initial seeds for supermassive black holes that start to appear all over the place just a few 100 million years afterwards. In other words, what we might be seeing here are sort of like these super early baby black holes that are going to be growing larger and larger, eventually reaching colossal sizes. But once again, at least for now, this is all very speculative. Here we need spectroscopic confirmations using some kind of a elemental observation from JWST in order to definitively establish redshifts, and in order to confirm that this is exactly what they are. For example, in this case, if we actually only find hydrogen, and it seems to be as far away as initially claimed, in that case, it potentially is black holes, and is extremely unlikely to be stars. Mostly because for stars we do expect to see something else, like for example, carbon, oxygen, and lithium. And so, for now at least, we don't really know if this is some kind of a young stellar population produced through means we're not able to explain, or some kind of a really early accreting black hole that would confirm the existence of primordial black holes. Either way, what is certain is that many of these new observations from the James Webb seem to continuously change cosmological preconception about those few 100 million years following the Big Bang that constitute the cosmic dawn. And that's because so many unusual luminous objects have already been discovered, and many of them are just kind of difficult to explain. And so this early period, 100 to 350 million years after the Big Bang, marks a bizarre rise of very strange objects that seem to be bright enough and powerful enough to be visible billions and billions of light years away. Right now, the only thing we can see for sure is that the early universe might have been a diverse and active place, potentially containing both black holes and early stellar populations, but with somewhat different properties to what we have in a much older universe. Or at least that's the assumption for now. Honestly, at this point, I don't think anybody can answer these questions yet. And so, as I mentioned before, the next crucial step is to obtain spectroscopic observations. And so once we have these specific emission lines from, for example, hydrogen, or potentially some other signals coming from these objects, we can possibly come to certain conclusions. But I guess what's crazy about these observations is that this is actually pushing the JWST's limit to its maximum. By design, the telescope was supposed to observe things up to about a redshift of 30 or just under 100 million years following the Big Bang. And here we have these objects that seem to be just at that limit. But because these are still early discoveries, we have to be cautiously optimistic and acknowledge the possibility that maybe this is something else entirely, and maybe these objects are just much closer, and some of the data was misinterpreted early on. Either way, we'll definitely come back and discuss these discoveries a little bit more in the next few months, once there are some additional observations. Until then, check out some of the previous videos on similar topics in the description below. Thank you for watching, subscribe, come back tomorrow to learn something else, support this channel on Patreon where you can find additional videos without any ads, and can DM me directly, or by joining the channel membership that grants you early access. Or maybe by buying the Wonderful Person t-shirt with a JWST image as the centerpiece. Anyway, I'll see you tomorrow, stay wonderful, and as always, bye bye.